What if everything we know about human history is wrong? Beneath the oceans, buried in deserts, and hidden beneath dense jungles lie ancient structures, so massive, so precise, they defy explanation. Megalithic stones carved with tools we supposedly didn't have. Pyramids older than civilization itself. Legends echo from the Andes to the temples of Southeast Asia, whispering tales of forgotten eras. Civilizations that rose and fell long before our recorded history even began. Could it be that we are not the first advanced society to walk this earth? That long before Sumerians etched cuneiform or the dynasties of Palestine rose and fell, another world, one entirely lost to time, thrived? This isn't about aliens or fantasy. It's about anomalies, real, documented, unexplained. It's about footprints in stone, maps showing ice-free poles, and architectural marvels aligned perfectly with stars we only recently began to understand. What are we missing? And why has history chosen to forget? So sit back, relax, and let's dive into the shadows of deep time, into the mysteries of pre-human civilization. What we uncover may change the way you see our past, forever. In the shadow of time, where stone holds the memory of Earth's deep past, the Badlands whisper secrets older than humanity itself. Layer upon layer of sediment tells a story, not of centuries or even millennia, but of hundreds of millions of years. Geologists will tell you these rocks date back to the late Cretaceous and Paleogene periods, a time of mass extinctions, continental shifts, and the slow, relentless sculpting of the world we know today. But if we dig deeper, not just into the ground, but into our assumptions, another possibility emerges, a possibility that is both unsettling and awe-inspiring. It is known as the Silurian Hypothesis. The name, borrowed from a fictional race of ancient reptiles in British science fiction, proposes a scientific question, not a claim. Could an industrial civilization have existed on Earth long before humans, millions, even hundreds of millions of years ago, and then vanished without a trace? On the surface, it sounds improbable. After all, modern civilization has only existed for a mere 10,000 years. Our most enduring structures, stone monuments, cities, artifacts, barely scratch the surface of geological time. And yet, the Earth is 4.5 billion years old. The age of dinosaurs ended 66 million years ago. The Silurian period, for which the hypothesis is named, ended over 419 million years ago. So, what could remain of a civilization that old? Would anything at all be left? We begin in the heart of the Atlantic Ocean, at a boundary of rock known as the Paleocene-Eocene Thermal Maximum, or PETM. Roughly 56 million years ago, a mysterious surge in carbon dioxide caused global temperatures to rise rapidly. It was a period of intense climate disruption, eerily similar to what we are experiencing today, but without the presence of human industry. The cause of the PETM remains unclear. Volcanic activity is one possibility. Another is the release of methane hydrates from deep beneath the sea floor. But there are those who ask a different kind of question. What if this event, or others like it, was the result of a civilization, advanced, industrialized, altering its environment just as we are now? A provocative thought, but is it possible? Modern industrial activity leaves certain geological fingerprints, synthetic chemicals like plastics, rare earth metals, radioactive isotopes, and a sharp spike in carbon emissions. These markers, in theory, could be preserved in the geologic record. But over millions of years, tectonic activity, erosion, and the constant recycling of Earth's crust could erase nearly all evidence. Still, some things might remain. For instance, sediment layers with unexplained isotope anomalies, patterns of extinction without clear causes, or deep-sea deposits of materials that suggest rapid planet-wide change. In Egypt's western desert, geologists discovered what appears to be ancient glass, formed not by volcanoes but possibly by intense heat and pressure, consistent with a nuclear-level explosion. Mainstream science attributes this to meteor impacts, but the resemblance is striking. In southern Palestine, archaeologists have uncovered traces of vitrified stone and fused sand in prehistoric layers, again attributed to natural events. But is it possible that we're misinterpreting something far older? At the same time, researchers in Antarctica have identified fossilized rainforests beneath the ice, indicating the continent once hosted lush vegetation, possibly as recently as 90 million years ago. If conditions once allowed for such ecosystems, could they have also supported intelligent life? Not humans, of course, but something else, something we no longer remember. The fossil record is incomplete. Mass extinctions, like the one at the end of the Permian period, often called the Great Dying, wiped out over 90% of marine species and 70% of terrestrial species. Entire ecosystems vanished. If a civilization had existed then, how would we ever know? Of course, the Silurian Hypothesis is not without its critics. Many scientists argue that an industrial society leaves behind unmistakable signs: steel, concrete, plastics, that should endure in some form. And yet, consider this. If humanity were to disappear today, how long would it take for nature to reclaim our cities? In 10,000 years, most structures would collapse. In 100,000 years, few recognizable traces would remain. In 1 million years, virtually nothing. Now stretch that scale to 100 million years. Would even our most iconic cities survive? There are places where mystery lingers. In India, the ruins of Mohenjo-Daro exhibit vitrified stone melted at high temperatures. While traditionally linked to natural disaster or kiln-based metallurgy, some theories suggest an ancient energy source or catastrophic heat. Again, these ideas dwell on the fringe, but they remain unproven, not disproven. In the Pacific, submerged structures off the coast of Yonaguni, Japan, resemble stepped pyramids and stone terraces. Are they man-made, or simply an unusual geological formation shaped by erosion? The jury is still out, but time is the greatest enemy of certainty. Our planet's surface is restless. Oceans rise and fall, continents drift. The past is buried, folded, subducted into the mantle, crushed under the weight of eons. Could an entire civilization have come and gone between the age of trilobites and the reign of dinosaurs, leaving only whispers in stone? If intelligence is not a uniquely human trait, but a potential outcome of evolution, then perhaps the rise of sentient, tool-using beings has happened more than once. Perhaps intelligence is not an anomaly, but a recurring pattern, a wave that crests and crashes again and again across the canvas of deep time. What if we are not the beginning, but just the latest chapter? Somewhere, in the folds of the Earth's crust, may lie the final traces of a world we've never known, a civilization without a name, a history without a record, and a question we may never fully answer. The deeper we dig, the more we must ask, how much have we forgotten, and what still waits to be discovered? Stay with us as we continue our journey through Earth's lost possibilities. The Earth holds many secrets, but some, it seems, lie not just in the rocks beneath our feet, but in the echoes of ancient stories passed down through time. As we leave behind the haunting implications of the Silurian Hypothesis, another mystery quietly emerges, one rooted not in fossil layers or isotope anomalies, but in words written over 2,000 years ago by the philosopher Plato. In his dialogues, Timaeus and Critias, Plato describes a lost world, a powerful island empire beyond the Pillars of Heracles, the modern-day Strait of Gibraltar. He calls it Atlantis. He speaks of a land rich in resources and culture, with grand architecture, complex irrigation systems, and a military force capable of dominating continents. But according to the story, Atlantis grew corrupt, and in a single day and night of misfortune, it was swallowed by the sea, lost forever. To most scholars, this is a myth, a philosophical allegory meant to illustrate moral decay and the fall of hubris. Yet the details in Plato's account are curiously specific. The layout of the capital city in concentric rings, the use of orichalcum, an enigmatic metal, the measurement of distances and timelines. He places the fall of Atlantis some 9,000 years before Solon, the Athenian lawmaker from whom Plato claimed to receive the tale. That would place Atlantis at around 9,600 BC, long before any known civilization. Is it possible, then, that Plato's story, if not entirely factual, was a distorted memory of something real? A memory of a world that existed long before Sumer, before dynastic Egypt, before even the known remnants of Göbekli Tepe or Jericho? If so, it would not be the Atlantis we see in fantasy novels or Hollywood films, but something stranger, older, and far more complex. Across the globe, archaeological anomalies invite comparisons. In southern Turkey, the site of Göbekli Tepe, dated to nearly 9,600 BC, defies our understanding of the Neolithic era. There, massive stone pillars, many over 16 feet tall, are arranged in ceremonial circles. Carvings of animals and abstract symbols decorate the limestone surfaces. No evidence of agriculture has been found, yet the people who built this place had the organization, resources, and knowledge to move and shape megaliths with astonishing precision. Who were they? And how did they acquire such skills at a time when most of humanity, we assume, still lived in small, nomadic groups? Further west, in the Atlantic waters near Spain and Morocco, sonar mapping has revealed strange rectilinear formations beneath the seabed. While often dismissed as natural geology, the geometry is difficult to ignore. Off the coast of Cuba, in deep waters inaccessible to casual divers, a joint Cuban-Canadian team in the early 2000s claimed to have discovered symmetrical, stone-like structures that resembled ancient architecture. Again, the findings remain unconfirmed, wrapped in secrecy and logistical challenges. But why does this myth of a sunken world persist across cultures? In the Indian subcontinent, Hindu texts speak of Dwarka, a magnificent coastal city ruled by Lord Krishna. According to legend, the city sank beneath the waves after Krishna's departure from Earth. Off the modern coast of Gujarat, marine archaeologists have discovered stone structures and pottery in submerged areas, some possibly dating to 9,000 years ago, though debated. In Palestine and nearby Mesopotamian regions, flood myths abound. The Epic of Gilgamesh, the tale of Utnapishtim, and later, the biblical flood story. These narratives span cultures and continents, from Mesoamerican traditions to the myths of the Aboriginal Dreamtime in Australia. Could they all be distant echoes of a global memory? A memory not of one Atlantis, but of many. Cities, societies, even entire cultures, lost to time by rising seas, shifting lands, or sudden catastrophe. Mainstream geology tells us that the last ice age ended roughly 11,700 years ago at the dawn of the Holocene epoch. During this transition, global sea levels rose by over 400 feet, flooding vast coastal plains. Areas that would have been ideal for early settlements, temperate, fertile, and close to the ocean, are now far beneath the waves. If early civilizations had emerged in these now submerged regions, their ruins could lie hundreds of feet underwater, buried in sediment and silence. Plato may have drawn from older Egyptian or Mesopotamian sources. The temple priests of Sais, according to his account, spoke of ancient times and cataclysms. Could their records have preserved distant memories, half-remembered, half-reimagined, of societies that predated our known past? And what of the strange alignments? The Great Pyramid of Giza, while built much later in around 2500 BC, is aligned with extraordinary astronomical precision. Some have argued that its position relative to the stars mirrors the Orion Belt during a time far older than accepted timelines allow, around 10,500 BC. Though widely contested, the suggestion continues to stir debate. Were the builders of these ancient monuments inheritors of a lost knowledge? Echoes of something once widespread, now scattered in pieces across the world? We do not know. We only know this: history, as we understand it, is incomplete. The story of humanity is often told as a linear ascent, from stone tools to skyscrapers. But what if that line is not so straight? What if there were dips, disappearances, entire chapters erased by floods, quakes, or time itself? What if Atlantis is not a single place, but a symbol, a placeholder for a forgotten epoch? A world not lost beneath fantasy, but buried beneath layers of caution and disbelief. As we continue to explore the remnants of our planet's deep past, we must ask, how much have we truly uncovered, and how much remains waiting, hidden beneath sand, sea, and silence? The echoes of Atlantis may never give us a definitive answer, but perhaps, just perhaps, they are not echoes of myth, but memory. Memory of a civilization not ours, yet not entirely alien either. A civilization that rose, shined briefly against the void of deep time, and then, like so many before and perhaps after, was washed away. What if the sea didn't just swallow a city, but an entire era? And what if we are only just beginning to remember? From the crumbled echoes of Plato's Atlantis, half legend, half memory, we now shift our gaze even deeper. Beyond myth, beyond even ruins, into the blank spaces where nothing remains. The fossil beds of Burgess Shale, high in the Canadian Rockies, rest in an ancient, silent cradle of stone. Mist coils around jagged cliffs. Beneath the surface, within the fine-grained slate, lie some of the oldest and most exquisite fossils ever discovered. Imprints of soft-bodied marine life that lived over 500 million years ago. Creatures frozen in time, preserved not by chance, but by rare and delicate conditions. A vanished world captured in layers of shale no thicker than a book's page. And yet, between these pages of Earth's history, entire chapters are missing. This is the Fossil Gap Conundrum. Despite more than 2 centuries of paleontological discovery, the fossil record remains deeply incomplete. There are moments of great clarity, epochs where species, ecosystems, and evolutionary lineages are well represented. But surrounding these are vast, stubborn silences, periods where life must have existed, but left no trace behind. Why? We know fossilization is rare. It requires precise environmental conditions, rapid burial, mineral-rich waters, the absence of scavengers. Most living things decompose into nothing, lost within years or decades. Only a sliver of life is ever preserved. And yet, even with this understanding, some gaps remain so wide, so strangely empty, that they raise uncomfortable questions. One of the most striking examples is the Cambrian explosion, around 541 million years ago. Before this event, for billions of years, life on Earth consisted mostly of single-celled organisms, with occasional multicellular colonies. But then, suddenly, geologically speaking, complex life burst onto the scene. Trilobites, brachiopods, mollusks, worms with nervous systems and visual organs. Nearly all the major animal phyla appeared within just 20 to 25 million years. Where did they come from? What forces triggered this explosion of diversity? Mainstream science offers several possible explanations. Changes in ocean chemistry, increased oxygen levels, the evolution of predation. But these answers don't fill the gap, they merely frame it. What's missing is the gradual buildup, the transitional forms, the steps between microscopic simplicity and macroscopic complexity. Why don't we see more of the in-between? Could those forms have existed and simply failed to fossilize? Or were they obliterated by heat, tectonics, or time itself before they could leave a mark? The fossil gaps are not limited to the deep past. More recent periods also exhibit strange silences. Between the end of the Ediacaran biota and the beginning of the Cambrian, there is a sudden, puzzling extinction, a vanishing of soft-bodied organisms replaced by shell-bearing newcomers. Similarly, between mass extinctions, we find intervals where evolutionary innovation seems to stall or disappear. Species appear, persist, and then vanish without obvious cause. The Permian-Triassic boundary, around 252 million years ago, saw the loss of over 90% of marine species. Yet what followed was not immediate rebirth, but a long, murky recovery, with little preserved evidence of life's early return. Why is nature at times so silent? And what if these absences are not purely biological? Some researchers have proposed an uncomfortable possibility, that the gaps might reflect not just what died, but what lived and then vanished so thoroughly it left no fossil, no tool, no ruin. If a civilization, biological, intelligent, perhaps not unlike our own, existed in one of these blank spaces, could we even detect it? The Silurian Hypothesis, as we previously explored, suggests that an industrial society might leave behind a geochemical fingerprint, isotopic shifts, synthetic molecules, carbon anomalies. But these too can be blurred by time, eroded by the planet's churn. A single civilization, lasting only tens of thousands of years, might never leave a recognizable fossil, especially if its populations were small or its structures made of organic materials. Cities built in coastal regions, now submerged, might be buried beyond reach, and bones, unless buried swiftly, would disintegrate into dust. Then there are the ghost lineages, organisms inferred from DNA or evolutionary models but missing entirely from the fossil record, a kind of biological déjà vu. We know they must have existed, but we cannot find them. Their absence haunts the timelines we try to construct. Could other, more complex gaps be hiding more than missing species? In 2013, scientists working in the Karoo Basin of South Africa noticed something peculiar. The fossil beds, so rich in Permian life, had a period of reduced diversity just before the mass extinction event. Not absent, but thinning, a quieting, as if something was draining from the world long before disaster struck. Was this an early warning sign? A natural lull? Or something else entirely? Further west, in the deserts of Palestine, rock layers reveal an uneven past, faunal turnover, shifts in climate, and unexplained disruptions. Yet no artifacts, no fossils beyond what we expect. Still, in these stretches of silence, we cannot help but wonder. What might have once stirred in the heat and sand? Of course, speculation cannot replace evidence, but evidence, as we've seen, does not always survive. Perhaps we are only beginning to ask the right questions. Perhaps the Earth, patient and ancient, holds memories deeper than bones or stone, memories that pulse quietly through the anomalies, the gaps, the mysteries that linger just beyond reach. What lived in those blank pages? What forces shaped the world and then withdrew without a trace? Or what vanished, not with a bang, but with a silence so complete we almost forgot it ever was? The fossil record, for all its beauty and detail, is a broken mirror. We see fragments, faces, forms, outlines, but rarely the whole. Between the reflections, the dark glass waits, and in that waiting, we are left to wonder. Beneath the still waters of the Amazon River, where the forest breathes in fog and time seems to hold its breath, lie strange geometric mounds. Arranged in patterns, circles, squares, long corridors, they suggest deliberate design, yet no one knows who made them. No records, no legends, only the shape of intention, softened by centuries of rain and roots. They are not alone. From the deserts of Palestine to the buried coastlines of India, from the muddy depths off the coast of Cuba to the unexplored basins of Antarctica, Earth is strewn with scattered anomalies, some natural, some artificial, some still undecided. But for all the whispers of a forgotten past, for all the myths, the fossil gaps, and the ancient structures, there remains a haunting absence. Where are the technosignatures? If an advanced civilization once existed on this planet, long before humans, then where is its footprint? Where are the tools, the debris, the unmistakable signs of industry? Where are the artifacts that science cannot deny? We live in an era saturated with waste. Plastics in every ocean trench, satellites circling in decaying orbits, radioactive isotopes embedded in the soil. These are the markers we leave behind, a planetary layer of human activity. So if we vanish tomorrow and another species emerges 1,000,000 years from now, would they find us? The technosignature absence puzzle is one of the most perplexing challenges to the theory of pre-human civilizations. It asks not why a civilization may have disappeared, but why we cannot find any evidence of it. And yet, perhaps the better question is, what kind of evidence should we expect to find after tens of millions of years? Let's begin with what we know about erosion and decay. Most of Earth's surface is dynamic. Mountains rise and fall. Forests burn and regrow. Rivers meander. Coastlines shift. Anything left on the surface is at constant risk of being ground to dust, covered in sediment, or pulled into the sea. Even our most enduring materials, steel, glass, plastic, deteriorate over time. A plastic bottle in the right conditions might last 500,000 years, but over millions of years, under heat, pressure, and microbial action, even that vanishes. Now imagine a civilization existing not 10,000 years ago, but 10 million or 100 million. The Earth has changed dramatically since then. Entire mountain ranges have risen and crumbled. Oceans have formed and dried. Forests have turned to deserts, then to grasslands, then to sea again. Could nature have erased everything? Consider the concept of urban stratigraphy, the buried layers of modern cities. Archaeologists studying ancient sites often find only foundations, post holes, and pottery shards. Organic materials rarely survive, and even these remnants are recent, historically speaking. Now scale that up to an industrial civilization. If their structures were made of metal, concrete, or even advanced composites, how would they survive the grinding gears of geologic time? And what if they didn't build like us at all? Our concept of civilization is tied to our own behavior, cityscapes, roads, monumental architecture. But what if a previous civilization developed differently? Perhaps they favored organic materials, structures grown rather than built, or tools that disintegrated cleanly back into the environment. Technologies that left minimal trace. A society advanced not through massive infrastructure, but through biological integration, quiet, efficient, and ephemeral. Would we even recognize such a civilization if we found it? In the mid-20th century, the rise of nuclear testing seeded the planet with radioactive isotopes, plutonium-244, technetium-99, that do not occur naturally in Earth's crust. Some researchers suggest these are true technosignatures, markers of intelligent activity. If similar isotopes appeared deep in the rock record, unexplainable by natural processes, it could imply a past technological epoch. Yet, to date, no such anomalies have been confirmed. Others look to microscopic clues. Certain industrial processes, mining, smelting, chemical refining, leave unique fingerprints. Heavy metal concentrations in soil, unnatural isotopic ratios, complex polymers. But again, time erases and redistributes. What isn't destroyed is scattered, lost in layers of rock far below reach. Still, there are places where nature itself preserves. Deep ice cores from Greenland and Antarctica, ocean sediment layers that reach back tens of millions of years. These contain continuous records of climate, chemistry, even volcanic eruptions. And while no unmistakable signs of ancient industry have been found, the question remains, are we asking the right questions, looking in the right places? Some theorists suggest we search for non-biological technofossils, components so alien to natural processes that they would stand out in any context, materials with molecular patterns that do not occur in nature. Data storage units, highly structured alloys. Yet such objects, if they exist, may be so few, so small, or so deeply buried, they've simply evaded detection. We also face the limits of our own expectations. What if an ancient intelligence evolved below the surface? In vast cave networks, shielded from cosmic threats, their technologies embedded in the crust itself. Or beneath the ocean, in deep-sea rift zones or long-lost continental shelves. The seabed is among the least explored regions of our planet, and the deeper we go, the less we understand. The absence of evidence is not evidence of absence, but neither is it proof of presence. We are left in the dark with only fragments, anomalies in stone, unexplained voids in life's timeline, tales that persist across cultures. Could it be that intelligent life once rose, reached its peak, and then, through catastrophe, collapse, or quiet withdrawal, was erased? And if so, what should remain? Is it possible that we've already passed over their remnants without recognition? That what we dismiss as natural formations, random chemical blips, or misidentified layers are, in fact, the echoes of something more? The Earth has a way of forgetting, but it also remembers, subtly, stubbornly, in the quiet details. The technosignature absence puzzle reminds us not of what we know, but of what we may have overlooked. And it challenges us to ask, what does intelligence truly leave behind? And when we finally find it, will we even know what we're looking at? Beneath the red earth of Central Africa, where the tropical heat shimmers and iron-rich soil bakes under the midday sun, lies a site that has puzzled scientists for decades. In the Oklo region of Gabon, near the edge of the ancient Franceville Basin, miners once dug deep in search of uranium. Routine work for an energy-hungry world. But in 1972, what they found was anything but routine. Uranium ore from the Oklo mine showed something no one expected. It had already been used. Specifically, the concentration of uranium-235, the fissile isotope used in nuclear reactors, was significantly lower than normal. It was as though a reactor had already operated here, billions of years ago. At first, this seemed impossible. How could there be a nuclear reactor, underground, natural or otherwise, that predates all of human civilization? One that appeared to have sustained a controlled chain reaction, not for minutes or hours, but for hundreds of thousands of years? The mystery deepened as researchers investigated further. They found distinct isotopic signatures, rare elements like neodymium and ruthenium, in patterns that closely match those produced by man-made nuclear reactors. Even more astonishing, the reaction byproducts had not leached away into the surrounding rock. Something had contained them, and so the scientific world turned its attention to Oklo. According to mainstream geology, the conditions required for a natural reactor to form were once, and perhaps only once, met here. Around 2 billion years ago, the uranium concentration in the region was high enough, and groundwater flowed through the rock in just the right way to allow a self-sustaining fission reaction to occur. The reaction would run for hours, shut down as heat boiled away the water, then restart once things cooled, a natural, cyclical nuclear reactor. It's a remarkable phenomenon, a genuine anomaly. But while most scientists accept the natural reactor explanation, some researchers and independent thinkers have raised deeper, more unsettling questions. Was it truly natural? If we discovered a similar system operating on another planet, underground, self-regulating, producing isotopic byproducts identical to a human reactor, would we be so quick to assume it was formed by chance? And if the conditions for such a reaction were so rare, only known to have occurred in Oklo, why were they perfect here? The reactor zones at Oklo, particularly Reactor Zone 2, display an eerie symmetry. The reaction sustained itself for approximately 500,000 years, with pauses and resumptions as though something, or someone, had designed it to be stable. The reaction zones are confined. The fuel was moderated by water, and the neutron absorbers, such as certain isotopes of samarium, acted in a way consistent with controlled operation. Is this merely coincidence? A once-in-a-planet alignment of geological luck? Or could it be something else entirely? Could the Oklo phenomenon be the buried remnant of a forgotten technology? There are no ruins, no tools, no evidence of structures, just the isotopes and the scars of reaction deep in the earth. Those who entertain more speculative theories suggest it may not have been a reactor as we understand it, an above-ground facility with cooling towers and fuel rods, but rather something more elemental. A reactor not built in the traditional sense, but triggered intentionally within the Earth itself. Perhaps not a power source for a city, but for something else. A beacon? A signal? A test? Some go further, wondering if the Oklo site was part of a larger network of energy management, now lost, operated by a civilization far older than any we've imagined, a civilization that worked with Earth's materials, embedded within its crust, and designed their systems to vanish without trace. Of course, these ideas lie far outside the mainstream. The scientific consensus remains firm. Oklo is a natural nuclear reactor, a rare and fascinating geological event that tells us about Earth's deep past, and nothing more. And yet, the deeper we look, the more questions emerge. The isotopic anomalies at Oklo match predictions for nuclear waste storage, but how did those isotopes stay so well contained? Why didn't they migrate as they do in every known example of modern waste leakage? What mechanism preserved the separation? And what of the timeline? 2 billion years is unimaginably long. It predates multicellular life. It predates even the Cambrian explosion. If intelligence existed then, it must have been unimaginably alien, biologically, technologically, philosophically. So different that we might not even recognize its works as artificial. So we must ask, how do we define evidence of intelligence? Is it a structure, a tool, a pattern, or could it be a reaction? Oklo remains unique. No other natural reactor has ever been found. And while researchers have tried to simulate the conditions that led to its formation, the results suggest that it was only possible because of very specific fleeting circumstances that no longer exist on Earth. Which brings us back to the central mystery. Was it nature, Or was it design? Is the Oklo phenomenon a once-in-a-universe coincidence? Or could it be the last whisper of something we've forgotten or never knew? For now, the uranium mines of Gabon are quiet, the reactors long extinguished, the isotopes sleep in silence beneath ancient rock, and the truth, whatever it may be, remains just beyond reach, held tight in the memory of stone. What if Oklo is not an outlier, but a clue? And what else lies hidden beneath the surface, waiting for us to recognize what we've long ignored? The Oklo phenomenon challenges our understanding of natural systems, blurring the boundary between accident and design. But as we step beyond the ancient uranium beds of Gabon, a new mystery calls from the deepest, darkest reaches of our world. A realm so vast, so unexplored, that it may as well be another planet. The deep sea. Beneath the surface of Earth's oceans lies a hidden world. Cold, pressurized, and lightless. It covers more than 60% of the planet's surface, yet we've mapped only a fraction of it. In many ways, we know more about the surface of the Moon, or Mars, than we do about the floor of our own oceans. It is here, in this silence and darkness, that another question emerges. Could entire epochs of intelligent life have evolved in the deep, unseen, unrecorded, and now forgotten? At first glance, the idea seems far-fetched. Life in the deep sea is extreme, slow-moving, adapted to crushing pressures and eternal darkness. But as we've come to learn, life thrives in the most unlikely of places. In 1977, scientists exploring the Galapagos Rift discovered something that transformed our understanding of biology: hydrothermal vents. Spewing scalding water rich in minerals, these vents formed oases of life. Tube worms, blind shrimp, sulfur-eating bacteria, all thriving without sunlight. An entire food chain powered not by photosynthesis, but by chemosynthesis. Before this discovery, life without sunlight was considered impossible. Now we know that hydrothermal ecosystems exist around the globe. These ecosystems are ancient, possibly as old as life itself, and they've survived countless planetary catastrophes. But what if they nurtured more than microbes and worms? What if, over millions or hundreds of millions of years, the conditions around these deep-sea vents gave rise to something more? Not simply survival, but awareness, tool use, language, culture. The challenges of deep-sea life are severe, yet evolution is persistent. In shallow waters, cephalopods, particularly octopuses, have demonstrated remarkable intelligence, problem-solving, memory, even play. Their nervous systems are radically different from ours, yet they exhibit traits we associate with sentient thought. Now imagine an evolutionary branch of cephalopods, or something entirely unknown, given not thousands but millions of years to evolve, adapt, and expand in an isolated realm, shielded from asteroid impacts, climate collapse, and surface extinction events. What would a civilization look like in the abyss? It would not build cities in the way we imagine. There would be no stone monuments, no metal towers, no written records on clay tablets. Structures might be organic, bioengineered from living materials, invisible to sonar or satellites. Tools might be grown, not forged. Energy could be harvested from thermal gradients or biological means. Communication could occur through color, pressure pulses, or electric fields, undetectable by conventional methods. If such a civilization had ever existed, it might leave behind no obvious technosignature. No fossilized bones, no crumbled buildings. But perhaps, if we looked closely enough, we'd find the traces in anomalies, unusual formations on the seafloor, symmetrical patterns at impossible depths, or artificial-looking structures half buried under silt. In 2001, sonar scans off the coast of western Cuba revealed what some researchers interpreted as geometric shapes, rectangles, pyramids, and grid-like formations at a depth of 2,000 feet. The Cuban government, along with a Canadian exploration team, recorded the data but never released full findings. Some argue it was an illusion of sonar interference. Others remain unconvinced. Similar claims have emerged near the coast of Japan, where the Yonaguni Monument lies beneath the waves. Sharp, terraced features that resemble ziggurats or temples have sparked debate for decades. Are they the result of natural tectonic activity, or the remnants of a culture swallowed by the sea during the end of the last ice age? Mainstream geology leans toward natural formation, but the patterns remain striking and unanswered. In the Indian Ocean, legends speak of Kumari Kandam, a sunken continent once home to a lost civilization. In the South Pacific, tales of Mu and Lemuria describe vast lands now drowned beneath endless waves. Are these simply myths? Or are they cultural memories of real, ancient landscapes lost to rising seas? And if the surface cultures remembered the sea swallowing land, what of civilizations that may have begun beneath the water? Could the ocean itself have once harbored an intelligent species that never needed to breathe air, that never emerged onto land, that never left a monument we could read? The difficulty lies not in believing such life could exist, but in proving it. Our tools are crude for such a search. Deep-sea exploration is expensive, dangerous, and limited. Most of the seafloor remains unvisited, unmapped. The technology needed to scan it with precision is only now becoming available. Even today, entire mountain ranges under the sea remain unnamed. Vast trenches plunge deeper than Everest is tall. What lies at the bottom of these abysses? Could it be that the deep sea is not only a place of life, but a place of history? A realm where intelligence once flickered into being, grew in isolation, and disappeared without notice, leaving behind nothing but questions and currents? Or perhaps it never disappeared at all. Perhaps it still waits in quiet places beyond our reach, watching, remembering, hidden in a world we barely understand. The ocean does not give up its secrets easily, but some mysteries are not lost. They are only submerged. And as we continue to peer into the deep, we must ask, are we truly alone in the history of this planet? Or are we simply the first species arrogant enough to assume we are? The deep sea offers us a shrouded mirror, one that reflects not just life in the present, but perhaps the ghosts of civilizations long submerged, long forgotten. Yet as vast and mysterious as the oceans are, an even deeper force shapes our world from beneath the surface, one that may be the greatest eraser of all. It begins not in the oceans or skies, but in the crust itself. At the edge of the Indian subcontinent, near the Himalayas, jagged peaks reach for the heavens, formed when two ancient plates collided. Here, stone tells a story written in compression and uplift. The marine fossils found high in these mountains whisper of vanished oceans and seafloors crumpled into continents. This is the quiet, relentless hand of tectonics. Earth is not a static planet. Its surface, our continents and seafloors, is broken into massive, moving plates that drift, collide, and vanish beneath one another. This constant churning of the planet's skin is known as plate tectonics. It is responsible for earthquakes, volcanoes, and the shifting shapes of land across geological time. But it may also be the mechanism by which the planet forgets. This is the core of what some call the planetary memory erasure hypothesis, a speculative but serious question. Could plate tectonics have wiped clean all evidence of a global civilization that existed long before ours? We often think of history in terms of what has been preserved, ruins, artifacts, fossils. But what if the absence of evidence is not because a thing never existed, but because the planet itself consumed it. Subduction zones, the deep trenches where one tectonic plate slides beneath another, are Earth's great recycling centers. Here, rock is melted into magma, crust is pulled into the mantle, and anything resting upon that crust, cities, tools, monuments, is ground down, incinerated, and lost. The process is slow, but over millions of years, it is absolute. Entire oceanic plates disappear beneath continents. Mountains rise and are weathered down. Volcanoes erupt, covering landscapes in ash and lava. Glaciers scrape the land bare. In just 100 million years, the surface of the Earth can be almost entirely rebuilt. To put this in perspective, the oldest stretches of ocean floor on Earth are no more than 200 million years old, less than 5% of Earth's total age. The rest has been destroyed and replaced. If a seafaring civilization had existed 500 million years ago, their harbors and coastal cities, if built on oceanic crust, would be long gone. Even the continents are not immune. Ancient land masses have fragmented, collided, and been reassembled multiple times in supercontinental cycles. Gondwana, Pangaea, Rodinia, names of lost worlds that rose and vanished before humans ever emerged. So what happens to memory in a world that recycles its own skin? Could there have been a civilization, not just regional but global, tens or even hundreds of millions of years ago, completely erased by tectonic movement? There are no known artifacts that support this, but given the nature of plate tectonics, would we even expect to find any? Our cities, highways, and monuments seem durable now, but they are temporary structures resting on a restless surface. Left untouched, most of human civilization would disappear in just tens of thousands of years. In 1 million years, nearly everything above ground would crumble. In 10 million, there would be almost nothing left. And after 100 million years, if our cities sat atop a plate that was eventually subducted, they would be gone entirely. Even synthetic materials, like plastics or radioactive isotopes, might be transformed beyond recognition by the intense heat and pressure of the mantle. And yet, Earth's geological record does contain sudden shifts, mass extinctions, climate spikes, isotope anomalies, moments of mystery. The causes are often debated: volcanism, asteroid impacts, methane release. But what if some of these shifts just possibly reflected the rise or fall of something intelligent? Consider the end Permian extinction about 252 million years ago, the most severe extinction event in Earth's history. More than 90% of marine species and 70% of terrestrial species vanished. The exact trigger remains uncertain. Could an advanced civilization have existed in that era and triggered a planet-wide collapse? We cannot say. The rocks are mostly silent. The deepest clues would not be fossils or tools, but chemical markers. Carbon isotope shifts, unusual metal concentrations, synthetic compounds. But even those can be ambiguous, and over hundreds of millions of years, they too can be diluted, reworked, or destroyed. What makes the planetary memory erasure hypothesis compelling isn't that we've found proof of a lost civilization, but that we may never be able to. Unlike Mars or the Moon, dead worlds with preserved surfaces, Earth is alive. It is both a cradle of life and a relentless destroyer of its own past. We build monuments to endure. We carve names into stone. But stone itself, on this planet, is temporary. So we must ask, what is the lifespan of memory on a living world? Could the silence in the geological record be not a denial, but a consequence? What if Earth is not a keeper of secrets, but a planet that forgets? And if a civilization once walked this Earth long before us, could their final legacy be the very processes that now hide their existence? We may never know. But as we continue to explore the mysteries buried beneath mountains, lost beneath oceans, and melted into the mantle, the question remains: how much of Earth's history has been erased, not by time alone, but by the planet itself? As we've seen, Earth may be a world that forgets, its crust reworked by time, its memories erased by tectonics. But what if some secrets weren't destroyed, only buried, preserved beneath layers of silence and ice? We now turn our attention to the coldest, most remote continent on Earth, Antarctica, a place of white desolation. Winds howl across its barren plateaus. Ice sheets stretch for thousands of kilometers, locking away 90% of the planet's fresh water. Temperatures plunge below 80 degrees. It is inhospitable, lifeless, a frozen void at the bottom of the world. And yet, beneath this icy tomb lies a continent unlike any other. For millions of years, Antarctica has worn the mask of an ice world. But this was not always so. Geological records and satellite imaging tell us that Antarctica was once green, lush, alive. Roughly 90 million years ago, during the mid-Cretaceous period, Antarctica was covered with temperate forests. Fossilized pollen, roots, and even entire tree trunks have been discovered in core samples. In 2018, scientists drilling beneath the West Antarctic ice sheet near Pine Island Glacier found the remnants of a 90-million-year-old rainforest, suggesting that this frozen land once teemed with life. Even earlier, around 250 million years ago, during the late Permian, Antarctica was connected to other southern land masses in the supercontinent Gondwana. It was home to amphibians, early reptiles, and dense plant life. Rivers flowed. Mountains stood bare and proud, not shrouded in ice. But what if Antarctica's history holds even more? What if, long before the ice, this forgotten continent was home to something astonishing? The idea is not without precedent. The continent is almost completely hidden beneath over a mile of solid ice, making it one of the least explored regions on the planet. Beneath that frozen shell lies an entire ancient landscape, mountain ranges, valleys, lakes, and possibly ruins? Some researchers point to the Gamburtsev Mountains, buried deep beneath East Antarctica. These mountains are as large as the European Alps, yet they remain completely hidden under the ice. Discovered by Soviet scientists in the 1950s through seismic measurements, they remain largely unmapped and unexplained. How did such a massive range form, and why does it resemble a mountain chain shaped by erosion, rather than the chaotic formations typical of volcanic origin? Even more curious are the subglacial lakes, like Lake Vostok. Trapped beneath nearly 4 kilometers of ice, Lake Vostok has been sealed off from the surface for over 15 million years. Some theorists wonder whether it might harbor unique forms of life, or preserve ancient organic material, untouched by time. As of today, exploration is limited, and the full extent of what lies beneath remains unknown. Then there is the enigma of ancient maps. The Piri Reis map, drawn in 1513 by the Ottoman admiral of the same name, has drawn fascination for centuries. It appears to depict the northern coastline of Antarctica, not as it exists today, but as it might appear ice-free. Some argue the map is based on older sources, predating modern exploration. If true, it would suggest that someone, long before our time, had knowledge of what lay beneath the southern ice cap. Mainstream scholars explain the Piri Reis map as a composite of known coastlines, misinterpreted and exaggerated by early cartographers. Yet the precision of some features, combined with other early maps, such as those by Orontius Phineas and Buache, continues to raise eyebrows. Could these maps be echoes of a forgotten knowledge? A lost culture that once charted the globe during a time when Antarctica was habitable? Skeptics point out that Antarctica has been icebound for at least 34 million years, following the separation of South America and the establishment of the Antarctic Circumpolar Current. For a human-like civilization to exist there, it would have to date back far earlier than modern humans, possibly tens of millions of years before our species emerged. But that is precisely the mystery we're exploring. Could an intelligent species, evolved before humans, now lost to time, have once thrived on a temperate Antarctica? A civilization not like ours, but shaped by its own pressures, its own ecosystems, perhaps even one that vanished before the last great glaciation began? If so, its traces would be buried deep beneath layers of rock and ice, preserved but unreachable. Unlike other continents, where tectonic activity and erosion erase the past, Antarctica's ice may have acted as a shield, a tomb, not a grave. We may never know for sure. The logistical and political barriers to large-scale exploration under Antarctic ice are immense. The Antarctic Treaty limits human activity, prioritizing peace and scientific cooperation, but also slowing full access. Drilling beneath the thick ice sheet requires expensive, specialized technology. And once samples are retrieved, they often raise more questions than answers. Still, some claim that satellite imaging has revealed symmetrical shapes, grids, pyramidal formations beneath the ice. These images remain controversial, often dismissed as pareidolia, our tendency to see patterns in noise. But they continue to feed speculation that perhaps, just perhaps, Antarctica holds more than glaciers and stone. The question, then, is not just what lies beneath, but who, if anyone, was ever there. Is it possible that long before the human story began, another chapter was written here, in the warmth of a lost world at the bottom of the earth? And if so, is it now sealed away beneath layers of silence and frost, waiting for the ice to retreat once more? Antarctica, for all its desolation, may be one of the last places on Earth where deep time has been preserved. Not erased, but simply hidden. What would it mean if we found evidence of intelligence beneath that ice? And what if the truth has been frozen not for thousands, but for millions of years, locked in the heart of a continent that remembers what the rest of the world has long forgotten? As the frozen veil of Antarctica stirs our imaginations with what may lie sealed beneath its ancient ice, we turn now to an even deeper stratum of time, a period long before the first human, before the dinosaurs, before even the familiar outlines of the world we know had formed. We descend into the Permian period, the final chapter of the Paleozoic era. Roughly 299 to 252 million years ago, the Earth was a very different place. The continents were fused into a single supercontinent known as Pangaea, a vast, dry interior surrounded by a superocean called Panthalassa. The land was dominated by sprawling deserts, lush forests of seed ferns, and towering conifer-like trees. The skies were home to early flying insects. And on the ground and in the seas, life flourished. Amphibians, early reptiles, mollusks, trilobites, and armored fish, all part of a complex and diverse global ecosystem. And then, it ended. The Permian Triassic extinction event, often called the Great Dying, remains the most severe extinction in Earth's history. Over 90% of marine species and 70% of terrestrial vertebrates vanished. Insects, previously resilient to mass extinctions, were decimated. It took millions of years for life to recover. Scientists continue to debate the cause. The most widely accepted theory points to massive volcanic activity in what is now Siberia. The Siberian Traps, a region of basaltic lava fields, erupted for hundreds of thousands of years, releasing vast quantities of greenhouse gases. Global temperatures spiked. Oceans became acidic and anoxic. Methane may have been released from frozen reservoirs, accelerating the spiral. But the data reveals something stranger. The extinction was not a single moment. It unfolded in waves across hundreds of thousands of years, with fluctuations in carbon and oxygen isotopes, sharp transitions in sediment layers, and signs of biosphere collapse even before the peak of the volcanic activity. What if the Earth wasn't just dying from within, but from something more? What if the Great Dying was not only a natural catastrophe, but also a civilizational collapse? It's a speculative question, a daring one, but not without its foundations. If intelligent life had arisen during the late Permian, hundreds of millions of years before humanity, how would we know? The fossil record for this period is incomplete. Many Permian layers have been metamorphosed by heat and pressure. Others are buried deep beneath oceans or eroded by time. What we do have are snapshots, fragments of a once vibrant world, punctuated by abrupt disappearances and unexplained changes in the geochemical record. Some researchers have pointed to carbon isotope excursions, sharp changes in the ratio of carbon-13 to carbon-12 as potential markers of massive carbon release. In our modern world, similar shifts are associated with industrial emissions and burning fossil fuels. Could the same have happened then? Was there an event, perhaps even a civilization, that triggered a collapse, releasing carbon in volumes large enough to mirror the effects of our own Anthropocene? There are no buildings, no tools, no written records. But then, could we expect to find any? If such a civilization existed, it would have evolved under conditions vastly different from ours. It might not have been bipedal. It may not have used metals or written language. Its culture, its technologies, its very biology might be utterly alien. And after 250 million years, most evidence, particularly anything exposed to surface erosion or plate tectonics, would be long gone. Yet there are strange hints. In South Africa's Karoo Basin, where Permian fossils are found in abundance, researchers have noticed a sharp decline in biodiversity, not only at the extinction peak, but in the tens of thousands of years leading up to it. It's as if the biosphere was slowly unraveling before the final blow. A pattern not unlike what we see today: species loss, climate shifts, and ecological imbalance. Elsewhere, in Eastern Europe and Asia, sediment layers from the Permian-Triassic boundary show rapid shifts in temperature, ocean chemistry, and biological productivity. It is as if the entire Earth entered a state of collapse, environmental, biological, and perhaps even systemic. Some speculative thinkers have proposed that an ancient civilization could have triggered the event through war, unsustainable energy practices, or environmental mismanagement. Others suggest it was a natural intelligence that reached a threshold and then declined, leaving only a trace in the planet's atmospheric chemistry. Of course, these are hypotheses without hard evidence, but they serve a purpose. They ask us to rethink our assumptions, to consider the possibility that intelligent life, if it emerged once, it could have emerged before. Not necessarily human-like, not necessarily technological in our sense of the word, but intelligent in a way shaped by its own evolutionary pressures. Could such a species have risen, flourished, and then vanished, its final moments folded into what we now call the Permian extinction? And if so, are we seeing echoes of that collapse in our own time? The fossil record speaks through silence as much as through presence. It is a story told in absences, in missing species, missing data, missing time. In the darkest rock layers of the late Permian, we find not answers, but questions. Questions written in carbon, in ash, in bones that abruptly disappear. What if the Great Dying wasn't just the end of an age, but the end of a civilization? And what if its memory is not gone, but simply buried, waiting for us to ask the right question, in the right way, at the right depth? As we continue this journey through Earth's forgotten possibilities, one thing becomes increasingly clear. Our planet may not remember us in stone, but in its rhythms, its scars, and its silences, it might remember something else. As we emerge from the shadow of the Permian, where a possible civilization may have ended with the most devastating extinction Earth has ever seen, we now drift further back, far beyond the age of reptiles or plants, beyond even multicellular life as we know it, into a span of time so ancient, so opaque, it borders on the mythic, the Pre-Cambrian. It is a name that evokes distance, not just in time, but in understanding. The Precambrian comprises nearly 90% of Earth's history, stretching from the planet's formation around 4.6 billion years ago to the sudden bloom of complex life 541 million years ago during the Cambrian explosion. For most of that immense span, Earth was a strange and evolving world, barren, volcanic, racked with meteor impacts, yet slowly stirring with the earliest signs of life. In this immense stretch of time, nearly 4 billion years, something curious remains. Stone formations, massive, geometric, sometimes eerily symmetrical, scattered across remote corners of the globe. They are often dismissed as natural formations, ancient rocks shaped by pressure, heat, erosion, and time. But some of them defy easy explanation. We begin in South Africa, in a region called Mpumalanga, where small, rounded stone spheres, many with grooves etched perfectly around their equators, have been found in deep Precambrian strata. Known as the Klerksdorp spheres, these metallic objects are embedded in pyrophyllite deposits dated to roughly 3 billion years ago. Geologists explain them as concretions, natural mineral formations created by the slow crystallization of material around a core shaped over eons. Yet, their symmetry, their polished surfaces, and the distinct grooves have puzzled researchers for decades. Some have likened them to bearings or mechanical components, artifacts out of time. If they are natural, they are stunning in their perfection. If they are not, what are they? Thousands of miles away, in Western Australia, we find the Bungle Bungle Range, a series of beehive-like sandstone domes rising from the earth in neat, rounded tiers. These structures, part of the Ord River Basin, are geologically dated to more than 350 million years, post-dating the Precambrian but shaped from far older sedimentary rock. Their striped layers of orange and gray, alternating with precision, give them the appearance of having been deliberately designed. Mainstream science attributes this to differences in moisture retention and microbial growth, natural banding over time. But from above, their arrangement and order stir something in the imagination. Could nature create structures that mimic design so convincingly? In Russia's Ural Mountains, a far stranger claim emerges. In the early 1990s, at the confluence of several rivers, microscopic coil-shaped objects were reportedly discovered deep in alluvial deposits. These nano-spirals, many no larger than a few millimeters, were made of tungsten and molybdenum, metals with extremely high melting points. The twist? The sediments in which they were found were dated to 100,000 years ago or older, far before the known use of metallurgy. Russian scientists initially speculated they were remnants of nanotechnology. Others dismissed them as contamination or industrial debris. But if the dating is accurate, and the objects genuinely ancient, what do they represent? The Precambrian, however, holds even greater mysteries in its bedrock. Consider banded iron formations, or BIFs. These massive, layered rock deposits stretch across Australia, Canada, and Greenland. They formed in Earth's early oceans, when dissolved iron interacted with newly produced oxygen from primitive photosynthesis. The result is layer upon layer of red and gray stone, rippling patterns that stretch for miles, laid down billions of years ago. But in places, these layers seem to bend, twist and arrange in ways that appear more than sedimentary. Some show near-perfect repeating geometries, interlocking patterns, structures that, at a glance, appear artificial. Of course, no one claims BIFs are the ruins of cities, but they raise a deeper question. What is the threshold between the natural and the constructed? If intelligent life had existed in the Precambrian, using unfamiliar materials or unfamiliar forms, would we recognize their work as distinct from geology? The human brain is drawn to patterns. We see faces in clouds, buildings in rocks. This tendency, known as pareidolia, may explain many of the claims of ancient megastructures. And yet, some patterns are difficult to ignore. In Greenland, one of Earth's oldest surviving crusts, formations like the Iswa Greenstone Belt contain rocks as old as 3.7 billion years. Within these rocks, carbon traces, possibly left by microbial life, hint at early biology. But what else might lie within these primeval layers? If a civilization ever existed in the Precambrian, millions or billions of years before any animal walked the earth, it would not have left behind steel or plastic. It might not have used language. Its structures, its tools, even its forms of consciousness could have been entirely alien. And its remnants, if any survive, would now be indistinguishable from the rocks that entombed them. Could it be, then, that what we see as formations are actually foundations? Not buildings in the traditional sense, but functions, machines or memory structures built from and into the Earth itself. These are questions science cannot yet answer, and perhaps may never. The Precambrian is Earth's black box, a vast archive written in a language we are only beginning to read. In the end, we return to the formations themselves, the stone spheres, the coiled nanostructures, the banded iron waves that stretch across entire landscapes. Each of them invites a choice, to see them as accidents, or as echoes. What if the Precambrian was not a void, but a veil? And what, if anything, waits behind it, still buried beneath the silence of stone? From the enigmatic symmetry of Precambrian formations, where stone walks the line between natural and constructed, we now widen our lens to a possibility rarely spoken aloud. Not just that a civilization once existed before us, but that it may have left. What if the intelligent life that once called Earth home is no longer here? High above the Namib Desert, a sea of rust-colored dunes stretches toward the horizon like frozen waves of time. The wind carves intricate patterns into the sand, ripples echoing a rhythm older than memory. In such a place, untouched by modern interference, one feels the weight of deep time pressing down. The sky is open, and the stars, silent, cold, eternal, seem almost to whisper. From here, we begin to contemplate the alien Earth-born intelligence hypothesis. Not alien as in visitors from another star, but alien in the sense of something not human, not modern, yet very much of this Earth. An ancient intelligence that emerged long before us, perhaps millions, even billions of years ago, and did not die in fire or stone, but instead departed. Mainstream science places the dawn of human civilization at around 10,000 BC, with the development of agriculture and permanent settlements. Our industrial age is scarcely 300 years old, and our ability to launch objects into space? Barely more than 6 decades, a blink in geological time. Yet in just that blink, we've left a measurable footprint on our planet and begun reaching beyond it, into orbit, to the moon, to Mars. The Voyager spacecraft now sails through interstellar space, carrying with it a golden record, a whisper to the stars that we were here. So what if we weren't the first? What if another intelligence, born not in myth but in deep time, achieved what we now attempt? Civilizations do not all follow the same trajectory. They do not all rise with pyramids and fall with war. An ancient, advanced culture might have had different priorities. Perhaps it did not build in stone, but in thought. Perhaps its structures were not meant to last, but to depart. If such a civilization became aware of its own extinction curve, whether from climate, catastrophe, or cosmic hazard, would it not have looked upward as we do? Sought refuge not in tunnels or towers, but among the stars. Our own species has already begun to dream of escape. Elon Musk's Mars vision, NASA's interstellar roadmaps, space habitats, genetic modification to survive off Earth. These are not fantasies. They are plans, in motion, designed to ensure that humanity does not vanish with Earth's next cataclysm. Why assume we are the first to reach this threshold? And if a prior civilization did leave, what would they have taken with them? Perhaps very little. Perhaps only their minds, encoded into machines or light, flung outward through wormholes or solar sails. Perhaps they left behind nothing, because they meant to leave nothing. Or perhaps they left behind something subtle, unintelligible to us, not monuments or tools, but ideas, embedded in DNA, in numbers, in the laws of physics, or the strange constants that define our universe. Some thinkers have proposed the possibility of directed panspermia, that life on Earth may have been seeded by an earlier intelligence, either from another world or, in this case, from Earth itself in an earlier era. Could a dying civilization have launched life as a kind of message, a final experiment, a long game of inheritance? Or did they never truly leave? In the myths of ancient cultures, we find recurring themes: sky people, star gods, beings who came from above and taught early humans. Quetzalcoatl, Osiris, the Anunnaki, the Apkallu. Were these simply metaphorical, the personification of knowledge and progress? Or were they distant memories, distorted by time, of beings who returned briefly to a world they once called home? Modern interpretations often twist these stories into tales of extraterrestrial visitation. But what if the truth is more grounded and more profound? What if the aliens we seek are not from other planets but from an earlier Earth? What if the intelligence we fear or hope to encounter out there once lived here and simply moved on? This hypothesis remains fringe, unprovable, and deeply speculative. But it opens doors to a different kind of legacy, one not buried in ruins but scattered in starlight. One that does not leave artifacts but absences, not traces but trajectories. Could it be that the stars have already received visitors, not from distant galaxies, but from Earth itself, long before we were born? Could it be that in seeking them, we are seeking ourselves? Our telescopes now scan exoplanets. We listen for signals. We search for Dyson spheres, for irregularities in light, for impossible movements. But perhaps we are looking in the wrong direction, not out, but back. Not for others, but for echoes. The alien Earth-born intelligence hypothesis reminds us that intelligence may not always die. It may choose to move, to transcend, to disappear not in failure but in transformation. And if that's true, then the question is not simply, were we the first? But rather, are we already the legacy of something older? Something that passed through this place long ago and left, not with fire but with silence? From the possibility of ancient Earth-born intelligences launching themselves into the stars, we return now to something left behind. Something measurable, material, and surprisingly persistent. Not a monument, not a machine, but a chemical echo. An imprint not carved into stone, but into the very atmosphere and oceans of our planet. We turn now to the carbon signature anomaly. Along the windswept coastlines of southern Greenland, scientists extract long cylindrical cores of ice, some over 2 miles deep. Each layer, pressed and preserved by time, tells the story of ancient air. Trapped within tiny bubbles are records of carbon dioxide levels, methane concentrations, dust, ash, even the memory of ancient temperatures. This is how we know the rhythms of Earth's past climates, its warmings, its coolings, its violent disruptions. But ice cores are not the only archives. Deep ocean sediment layers, carbonate rocks, and shale deposits all record another kind of history, the isotopic balance of carbon atoms through time. Most carbon on Earth exists in 2 stable forms, carbon-12 and carbon-13. Their ratio in ancient layers can reveal extraordinary truths, and sometimes disturbing questions. Throughout Earth's deep past, there have been spikes, abrupt, planet-wide increases in atmospheric carbon levels. These events often coincide with mass extinctions, climate upheaval, and major biological turnovers. The best known of these is the Paleocene-Eocene thermal maximum, or PETM, approximately 56 million years ago. During this period, global temperatures rose by up to 8 degrees Celsius. Arctic seas warmed to subtropical conditions. Ocean chemistry shifted. Many deep-sea organisms perished. And in the geologic record, we find a sharp negative carbon isotope excursion, a sudden increase in carbon-12 relative to carbon-13, the signature of massive carbon release. Traditionally, scientists attribute the PETM to natural processes, volcanic activity, the release of methane hydrates, or the breakdown of organic deposits. These remain the leading explanations. But others ask, what if the spike wasn't natural? What if, in some forgotten epoch, an intelligent species, industrial, expansive, carbon-fueled, triggered the same atmospheric shifts we're now causing, only tens of millions of years earlier? The idea is not as far-fetched as it might seem. In 2018, 2 NASA scientists, Dr. Gavin Schmidt and Dr. Adam Frank, posed this very question. In a peer-reviewed paper, they explored what they called the Silurian Hypothesis. Could we detect a prior industrial civilization in the geological record? Their answer, perhaps, but only under very specific conditions. Among the clearest indicators would be abrupt shifts in stable carbon isotope ratios, precisely what we see at events like the PETM. These spikes resemble the signature humanity is currently leaving in the rock record, a layer that future civilizations might one day study and puzzle over. The PETM is not the only anomaly. At the Permian-Triassic boundary, roughly 252 million years ago, we again find a dramatic carbon isotope excursion, coinciding with the most catastrophic extinction in Earth's history. Some models suggest carbon release levels rivaling or even exceeding modern emissions. Could it have been volcanic? Likely, but we don't fully understand the mechanism or the source. And the mysteries deepen when we examine other events. The Toarcian oceanic anoxic event around 183 million years ago, the Cretaceous oceanic anoxic events, and the late Devonian extinction. Each shows sharp planet-wide carbon disruptions, abrupt enough to defy slow geologic causes. Could industrialization have occurred in cycles, rising, falling, and vanishing, each time leaving only a chemical scar? It's an unsettling thought, but perhaps even more unsettling is what wouldn't remain. The carbon we emit today, via fossil fuel combustion, deforestation, concrete production, is rapidly altering the atmosphere. But in a million years, little of it will be traceable in the air. Instead, the legacy will lie in sediments, the ratio of carbon isotopes, the presence of fly ash, plastics, and trace metals. In tens of millions of years, only the isotopic imbalance may remain. So when we look backward and find these same signals, we're faced with an uncomfortable ambiguity, natural or artificial. The burden of proof remains with the natural, But our understanding is incomplete. Volcanic emissions, for example, do not fully account for the volume and rate of change seen in some carbon spikes. Methane hydrates, while potent, require triggers. And in some cases, the source of the carbon is still debated. What if Earth has experienced industrialization before? Not with cars or skyscrapers, but with something else, something adapted to the world as it was. Maybe they burned something different. Maybe their industries were based on chemistry we haven't yet rediscovered. Maybe they were biological, geological, or even ocean-based. Their waste long degraded, their memory erased, but their carbon lingers. The Earth doesn't judge what caused its changes, it simply records them. We are beginning to understand how to read that record, not just as climate scientists, but as archaeologists of deep time. And the question we now face is not simply, how did this happen? But who, if anyone, was here to cause it? Each spike is a mystery, a pulse in the geological heartbeat of the planet. And while the story we tell remains grounded in volcanic fire and ancient methane, the possibility of forgotten hands still lingers at the edge of the data. Could the carbon anomalies of Earth's past be more than natural? Could they be the last exhalations of civilizations lost? And if so, how many chapters of our planet's story remain unread, hidden not in monuments, but in molecules? The carbon signature anomalies leave behind questions not easily dismissed, chemical echoes that whisper of fire, disruption, and perhaps forgotten consequence. But what if the past held more than just environmental traces? What if it once held minds, hands, tools? Now, we journey to a stranger possibility, one rooted not in chemistry, but in action, in behavior. We ask, could tool-using species have existed in Earth's distant past and been wiped out long before humans ever appeared? This is the Triassic tool theory. In the arid red canyons of the American Southwest, where Triassic rock layers are exposed like open books, paleontologists have uncovered ancient tracks, footprints pressed into what was once soft mud. Some are the familiar three-toed marks of early theropod dinosaurs. Others resemble those of strange, now extinct reptiles. But among these trails, a few stand out, bipedal, symmetrical, and uncannily deliberate. These prints aren't proof of tools, but they remind us the Triassic period, spanning from 252 to 201 million years ago, was a time of experimentation in evolution. Following the devastation of the Permian extinction, life rebounded with energy. Reptiles diversified. Early archosaurs, the ancestors of both crocodiles and birds, began to spread. The world was changing. But what if among this explosion of life, intelligence flickered? The fossil record from the Triassic is patchy at best. Much of the planet's surface from that era has been buried, eroded, or subducted by tectonic activity. Fossils are rare, and behavior, especially advanced behavior, is nearly impossible to confirm without context. Yet intelligence does not require large brains alone. Tool use has evolved independently multiple times. Octopuses, crows, elephants, even sea otters demonstrate problem-solving and the manipulation of objects. Among early vertebrates, there were species with flexible limbs, forward-facing eyes, and potentially social behavior. One such group is the drepanosaurs, bizarre, chameleon-like reptiles with grasping claws and tails possibly used for support or balance. Though small, they show evidence of arboreal adaptation and intricate limb structure. Some paleontologists have speculated that they could manipulate objects, though no direct evidence exists. And what of the cynodonts, mammal-like reptiles that lived through the Triassic? These creatures were warm-blooded, possibly furred, and may have possessed whiskers or sensitive facial nerves. Some built burrows. Some had complex teeth, suggesting varied diets. Their brains were larger relative to body size than most of their reptilian contemporaries. In today's world, burrowing, warm-blooded animals like meerkats and prairie dogs engage in social behavior, warning calls, and rudimentary learning. Could Triassic cynodonts have done the same? Perhaps even more? The Triassic tool theory proposes that somewhere within this diverse array of early species, one or more evolved cognitive complexity. Not necessarily at the level of modern humans, but enough to begin shaping their environment, perhaps with stones, bones, or branches. If so, their legacy would be nearly invisible. Why? Because tools, particularly those made from organic materials or unworked stone, do not fossilize easily. A stick used for digging, a sharpened rock used to crack shells, a hollowed-out burrow repurposed as shelter. These behaviors leave minimal trace, especially after 200 million years. Even in the relatively recent archaeological record, stone tools less than 1 million years old are often debated. Context is everything. Without associated fossils, stratigraphic certainty, or repeated patterns, claims of ancient tool use are quickly dismissed. But what if we're simply not looking far enough back, or not recognizing what we see? In 2014, researchers in India discovered curious cleaver-like stones in sediments dated to approximately 1.5 million years ago, but some estimates suggest they may be even older. In Kenya, artifacts attributed to early Homo species were later found to predate Homo itself. If our own tool history is still being revised, what of those who may have come long before? Of course, critics argue that intelligence at the level of tool-making requires selective pressures that didn't exist in the Triassic, that brain size, metabolic demands, and environmental complexity weren't sufficient to foster such a leap. And yet, if tool use can emerge independently in cephalopods and corvids, is it so unthinkable that something reptilian or mammalian or neither might have reached that threshold in the deep past? The theory does not claim they built cities or developed language. It suggests only that intelligence, adaptable, tool-using, responsive intelligence, may not be as recent as we assume. That it may have emerged briefly long before us and been lost, and the Triassic period ended with another extinction, less famous than the one that followed the dinosaurs, but still devastating. Volcanic activity, climate chaos, and rising carbon dioxide levels are believed to have triggered widespread die-offs. Entire lineages disappeared. If any species had begun to innovate, to change how it lived, that spark may have been extinguished, leaving behind no monuments, no graves, only silence. And in that silence, a question. What if the story of intelligence on Earth is not one long rising arc, but a series of sparks? Brief illuminations, some burning longer than others, most fading before they could leave their mark. Could one of those sparks have flickered in the Triassic? And if so, what remains of it now? Only rock. And the possibility that the hands of time may have once held tools before us. Tools now vanished, their purpose forgotten, their memory waiting to be found, or never to be found at all. The possibility that tool-using creatures once roamed the Triassic Earth and then vanished before they could leave a lasting imprint invites us to rethink the very shape of intelligence. But now we move deeper still, into a time so ancient that the very air we breathe had yet to exist. A time before animals, before plants, even before complex cells. A time when the planet itself was being transformed, not by geology alone, but perhaps by life. We journey now to the Great Oxidation Event, one of the most profound and still most mysterious turning points in Earth's history. Imagine a shoreline nearly 3 billion years ago, The sun is dimmer than today, casting a soft amber hue over a world without green. The land is barren, the skies tinged orange and gray, thick with methane and carbon dioxide. There are no forests, no birds, no sound. Just microbial mats clinging to the edge of warm, shallow seas. Fragile colonies of single-celled life, barely more than chemistry with a boundary. And then, the air begins to change. Rocks from this period, preserved in ancient formations like the Pongola supergroup in southern Africa and the Hamersley Basin in Western Australia, tell a remarkable story. They reveal that around 2.4 billion years ago, oxygen, a rare and reactive gas at the time, began to accumulate in the atmosphere. It was a slow but dramatic shift known as the Great Oxidation Event, or GOE. Before this point, any free oxygen produced by photosynthetic microbes was immediately absorbed by iron in the oceans or other reducing elements in the environment. But at some point, these oxygen sinks became saturated. The oxygen had nowhere else to go, so it began to linger in the air. What followed was nothing short of a planetary revolution. Oxygen, though essential for complex life today, was toxic to most of the anaerobic organisms that dominated early Earth. The rise in atmospheric oxygen likely triggered one of the first great mass extinctions, wiping out vast swaths of microbial life that had thrived in an oxygen-free world. And yet, with that destruction came possibility. The new oxygenated atmosphere laid the foundation for complex metabolism, multicellular organisms, and eventually intelligent life. But here lies the mystery. Was this purely an accident of evolution, or was it a directed act? Mainstream science holds that cyanobacteria, microscopic photosynthetic organisms, were responsible for releasing oxygen as a byproduct of converting sunlight and carbon dioxide into energy. Over millions of years, their activity reshaped the biosphere. This is the accepted view. Life changed the planet through slow, unconscious biological processes. Yet some have asked a deeper, more provocative question. Could the Great Oxidation Event have been intentional? Could early microbial life have reached a level of collective complexity or proto-intelligence sufficient to alter the environment as a survival strategy, or as a form of engineered evolution? It may sound outlandish. After all, we are not talking about civilizations with tools or language, but nature has already shown us that intelligence is not confined to brains. Slime molds can solve mazes. Ant colonies behave like superorganisms. Neural-like signaling occurs even in plants and fungi. Could early microbial life, spread across the planet in vast interconnected colonies, have responded to global conditions with a kind of emergent agency? Consider this. The buildup of oxygen took place not all at once, but in waves. Geological evidence points to several false starts, periods where oxygen briefly accumulated, then vanished, before stabilizing permanently. These cycles suggest a feedback system more dynamic than simple chemical runoff. And there's another oddity. The GOE occurred long before complex life could benefit from it. In evolutionary terms, it was a remarkably forward-thinking move. So who or what benefited? The simplest answer is nobody at first. It was a mass extinction, a catastrophe. But over the next billion years, new life forms evolved to take advantage of the oxidized world. Aerobic respiration, far more efficient than anaerobic metabolism, allowed organisms to grow larger, interact more complexly, and eventually form the building blocks of animals. If the GOE was life's first great experiment with planetary engineering, was it also its first sacrifice? Could a microbial superorganism have chosen extinction in one form to enable life in another? This is the foundation of a fringe but fascinating theory that the Great Oxidation Event was not an accident, but a form of collective self-guided transformation. a planetary scale adaptation. Not intelligence in the way we understand it, but something more distributed, more subtle, more alien. It's important to be cautious here. No direct evidence suggests intent, no structures, no writings, no communications. But then again, what would intent look like in a world without neurons? What would agency look like when expressed by networks of cells across oceans? Perhaps intelligence does not always resemble us. Perhaps it doesn't build, speak, or even think, but flows, replicates, responds. Perhaps it leaves behind not tools, but atmospheres. If the GOE was life's first act of world-shaping, then it may have been the first in a series of forgotten revolutions, steps along a path not to dominance, but to transformation. A question remains, suspended like dust in ancient air. Was this the first act of conscious life changing the planet, or just the planet changing itself? And if it was intentional, what came next? What traces remain, not in fossils or artifacts, but in the chemistry of breath, the layers of stone, and the silence between extinctions? We still don't know, but somewhere in the ghost of ancient oxygen may lie the signature of the world's first experiment with destiny. From the silent breath of oxygen left behind by ancient microbial colonies, we now step into a chapter where life begins to take visible form, a sudden surge in biological creativity that defies the gradualism of evolution. A time when nature, it seems, tried everything all at once. It is here, in the depths of ancient seas, that we explore an even more provocative question. Did consciousness attempt an early start, 500 million years before humanity? This is the Cambrian intelligence theory. Beneath the jagged limestone cliffs of eastern Canada's Rocky Mountains lies one of the most important fossil sites ever discovered, the Burgess Shale. Here, embedded in dark slate, are the exquisitely preserved remains of creatures from over 500 million years ago, from the Cambrian period, when complex life first exploded onto the world stage. These fossils reveal a stunning variety of organisms, many of them unlike anything alive today. Opabinia, with 5 eyes and a backward-facing proboscis. Hallucigenia, a spiny worm walking on stilt-like legs. Anomaly, a fearsome predator with grasping limbs and compound eyes. It was a moment of evolutionary experimentation so extreme, so rapid, that it has puzzled scientists for over a century. Before the Cambrian, life on Earth was dominated by soft-bodied, simple organisms. Then, in the span of just 20 to 25 million years, nearly all the major animal body plans we recognize today, arthropods, mollusks, chordates, appeared in the fossil record. What caused this sudden leap? Standard theories suggest a combination of environmental and genetic factors: rising oxygen levels, changes in ocean chemistry, the evolution of the first true eyes, and the emergence of developmental genes like the Hox complex. All plausible, all grounded in evidence. But a deeper question haunts the edge of this narrative. Was this merely a biological explosion, or was something else stirring beneath the waves? Could the Cambrian have seen the first sparks, not just of form and function, but of mind? The Cambrian intelligence theory posits that during this great diversification, life may have taken its first tentative steps toward consciousness. Not in the sense of speech or society, but in perception, choice, even self-direction. Fossil evidence from the period shows increasing complexity in nervous systems, sensory organs, and behavioral adaptations. The trilobites, for instance, some of the earliest creatures with sophisticated compound eyes, may have been capable of advanced visual processing. Anomaly, with its predatory tools and agile movement, may have hunted with something resembling intention. Predator-prey dynamics, arms races of evolution, drive complexity. But could they also foster awareness? In modern animals, we know that cephalopods like octopuses and cuttlefish display remarkable intelligence despite being invertebrates. Their lineage may trace back to early Cambrian ancestors. Is it possible that, even then, neural networks were evolving toward something more than just reaction? Some researchers have begun to explore the concept of minimal consciousness, the idea that awareness exists on a gradient, not as an on-off switch. In this view, consciousness isn't something that suddenly appeared in primates or mammals, but something that emerged gradually, step by evolutionary step. Could the Cambrian have marked one of those early steps? We may never know for certain. The fossil record captures form, not thought, bones, not behavior, but indirect clues remain. The structure of early brains, or their precursors, can be inferred from the imprints left in fossilized heads. Some Cambrian organisms show evidence of ganglia, nerve cords, and sensory integration centers, tiny bundles of decision-making potential, the groundwork for what, one day, would become thought. More speculative are the claims from a few paleontologists that some Cambrian trace fossils, unusual burrow patterns, repeated behaviors in sediment layers, hint at more than just reflex. Could these patterns represent learning, memory, a primitive form of culture? And if so, what happened to it? The Cambrian burst did not last forever. Many of its strangest creatures vanished by the time of the Ordovician period, replaced by more specialized forms. If awareness did begin to flicker during this ancient time, it may have been smothered, snuffed out by extinction, or simply bypassed in favor of more efficient evolutionary strategies. But perhaps not all was lost. Perhaps the foundation laid during the Cambrian endured in quiet ways, in the branching nerves of sea stars, in the reflexes of crustaceans, in the scattered legacy of ancient neural codes that would one day awaken again, this time in creatures who walked the land. Could it be that the mind did not begin with us, but has been trying to emerge since the beginning? The Cambrian intelligence theory does not claim forgotten cities or vanished empires. It suggests something subtler, that perhaps, long before words or tools, before fire or bone, the spark of knowing, the first trembling sense of self, may have stirred in the currents of Cambrian seas. That deep beneath our inherited biology lies an older inheritance still, the memory of ancient perception, encoded in neurons shaped by eyes that once saw a world alien and wondrous. And so we are left with a final question. Was the Cambrian not only the explosion of life, but the dawn of experience? If so, then consciousness may not be a gift of the recent past, but a longing older than time itself. A mystery that began not with us, but with creatures we can barely imagine, drifting, crawling, and chasing through the shadows of ancient oceans. As we leave behind the flickering emergence of perception in the Cambrian seas, those first tentative brushes with consciousness, we move forward in time, yet remain deep in the ocean's hold. A different world now stirs beneath the surface. Forests begin to stretch across the land. Rivers twist between rising mountains, and in the water, new creatures evolve with unfamiliar shapes, armor, and, most curiously, minds. This is the Devonian period, often called the Age of Fishes. And it is here, amidst fossilized reef systems and silt-covered riverbeds, that we encounter one of the most puzzling anatomical clues in Earth's early evolutionary story: the Devonian Braincase Enigma. In the red sandstone cliffs of northern Scotland, near the shores of the ancient lake beds of the Old Red Sandstone Formation, paleontologists uncovered remarkably well-preserved skulls belonging to early vertebrates. These creatures, like Tiktaalik, Panderichthys, and Eusthenopteron, lived around 375 to 390 million years ago, and represent transitional forms between aquatic and terrestrial life. But within the mineralized cavities of their skulls lies something unexpected. CT scans and digital reconstructions of these fossils reveal unusually complex brain cases, structures that, by traditional understanding, seem more sophisticated than what their behavior would suggest. Some show expanded regions in the forebrain, unusual canal systems, and asymmetrical chambers, features typically associated with sensory integration and higher-order processing. For animals that are presumed to have lived relatively simple lives, hunting, swimming, breeding, why such intricate neural architecture? Mainstream evolutionary theory explains these features as pre-adaptations, traits that evolved for one function but later became useful in new ways. Just as feathers may have first evolved for insulation before being co-opted for flight, braincase complexity may have emerged for balance, spatial navigation, or electroreception. But here, the mystery deepens. In some Devonian species, these adaptations appear to arrive too early, too rapidly, and in combinations not easily explained by environmental pressures. Why would a fish living in shallow streams develop a braincase structure with features that wouldn't find full utility until life on land? One specimen, Romer's Gap Tiktaalik, displays a particularly robust cranial cavity that seems disproportionate to its known sensory needs. Another, Goganosus, shows advanced inner ear structures and a highly ossified braincase, unusual among its contemporaries. These creatures weren't simply developing better senses. They were developing internal environments for brains potentially more complex than the moment required. So we ask, were these just evolutionary flukes, or were they the beginning of something more? Could the Devonian have seen the early flirtation, not just with lungs and legs, but with thought? It's tempting to imagine a slow dawn of sentience, creeping alongside the transition from water to land. These creatures were explorers, moving from one realm to another. Did the neurological changes required for such a leap also lay the groundwork for more advanced cognition? We often think of consciousness as something binary, present in humans, absent elsewhere. But neuroscience increasingly reveals it as a spectrum, shaped not just by complexity, but by connection. A Devonian vertebrate may not have been self-aware in the way we are, but might it have been capable of choice, anticipation, even primitive planning? The Devonian braincase enigma invites this speculation not with monuments, but with microanatomy. It challenges us to consider that the seeds of intelligence were being sown not with the sudden arrival of humans, but with slow, cryptic innovations in the architecture of early brains. And the mystery doesn't end there. Some fossilized braincases from this era show asymmetrical features, left-right imbalances that, in modern animals, are often associated with lateralized brain function. This phenomenon is seen in birds, mammals, and even some fish today, where one hemisphere becomes specialized for tasks such as language, problem-solving, or emotional processing. Could lateralization have begun here? And if so, was it a byproduct of movement, environment, or something subtler? One theory suggests that these asymmetries may reflect early forms of tool use or environmental manipulation, behaviors that require not just reaction, but memory and preference. There is, of course, no direct evidence of tools from this time, but as we've seen with modern animals, octopuses using coconut shells, fish building nests, complex behavior can arise in environments we once assumed too primitive.
Could Devonian vertebrates have shown glimmers of this? Behavioral sophistication we cannot yet detect in the stone? Some researchers have proposed that our current fossil interpretation is limited by resolution. Microstructures in the fossil braincase may contain traces of neural patterning, blood vessel maps, or mineral ghosting of soft tissues that once nourished cognition. As imaging technology improves, we may yet uncover signs of brain evolution that point to more than survival, perhaps to thought, curiosity, or even social behavior. And then there is the question of disappearance. If the Devonian was indeed a starting point for early intelligence, why didn't it continue? Why didn't these lineages rise further? The Devonian ended with a series of extinction events, environmental shifts that wiped out many of the reef-building organisms and reshaped ecosystems. Perhaps the creatures with these unusual brain cases were simply in the wrong place, at the wrong time. Perhaps their minds, if they were beginning to form, were lost not to failure, but to chance. And so we are left with a trace, an empty cavity in stone, too complex for its time, too subtle for a clear answer. Did evolution simply overshoot the mark? Or did it try something that almost worked? The Devonian Braincase Enigma does not offer certainty, but it hints at the possibility that thought did not wait for primates or people, that the architecture of mind may have been taking shape long before the world was ready to receive it. And if that is true, if intelligence began reaching outward from the depths of time, then perhaps the history of sentience on Earth is not a singular path, but a pattern, one that begins and ends in silence over and over again. Until one day someone remembers to ask what came before. From the mysterious brain cases of Devonian creatures, those hollow chambers etched into stone like forgotten blueprints of emerging minds, we now turn to something even deeper, not deeper in complexity but in time. Buried not in bone, but in the bedrock of the Earth itself. We move into the silent depths of the Pre-Cambrian, and with it, into one of the strangest and most quietly controversial ideas in the study of ancient mysteries, the Precambrian mining theory. In the heart of southern Africa, the rocks of the Barberton Greenstone Belt shimmer with a strange, ancient luster. These are among the oldest exposed rocks on the surface of the Earth, dated at over 3.5 billion years old. Scattered across this terrain and in other Precambrian formations worldwide, from the Canadian Shield to the Pilbara Craton of Western Australia, are odd mineral seams and anomalies. Veins of gold, nickel, and uranium that seem, in some cases, unusually exposed, displaced, or depleted when compared to surrounding layers. This by itself isn't unusual. Geological forces are chaotic, relentless, and messy. Over billions of years, plate tectonics, hydrothermal activity, and natural erosion can twist and rearrange mineral deposits beyond recognition. But in a few isolated cases, certain patterns raise questions. Patterns that appear, at least to some observers, less like geological accident and more like intention. Some researchers have noted the presence of narrow, tunnel-like voids in ancient rock strata, structures that don't follow natural fault lines and that cut cleanly across different layers of mineralization. These features, often dismissed as the product of ancient fluid channels or metamorphic processes, have nonetheless drawn attention for their regularity and selective alignment with ore-rich zones. In other cases, specific elements, such as titanium, uranium, or rare earth metals, appear to be disproportionately reduced or absent from zones where, based on surrounding geology, they should exist in greater abundance, almost as if they were extracted. Could these anomalies be evidence, not of mining in the conventional sense, but of ancient extraction, and if so, by whom? Mainstream science maintains that all such features are explainable through known geological processes, and in most cases it likely is, but that hasn't stopped fringe theorists and independent researchers from raising the possibility that intelligent activity, millions or even billions of years ago, might leave behind only subtle, indirect scars. Not buildings, not tools, but shifts in mineral patterns that, to the trained eye, look oddly purposeful. Take, for instance, the uranium deposits of Oklo in Gabon. In a previous chapter, we explored this site as an example of a naturally occurring nuclear reactor, where, around 2 billion years ago, a unique combination of conditions allowed sustained fission reactions to take place. It is accepted today as a rare but natural geochemical phenomenon. And yet some have asked, what if Oklo wasn't the only site? What if ancient activity, now indistinguishable from geologic coincidence, left traces not in construction, but in alteration? After all, a civilization with different technological principles might not leave pyramids or pottery. Instead, it might drill or melt, transmute or dissolve, especially if its industry was underground or not based on the surface at all. In the Precambrian, there were no plants, no animals, no humans. But there was microbial life, complex, abundant, and perhaps, according to some interpretations, unusually dynamic. If any form of intelligence arose during this time, it may not have resembled us. Its operations might have been distributed, chemical, or deeply embedded in the planet's crust. What if it mined not for wealth, but for function? And if such activity occurred, how would it appear to us now, billions of years later? The Precambrian mining theory doesn't propose that evidence is being ignored. It suggests that we may not even know what to look for, that we might be mistaking intelligent scars for geologic ones because our frameworks for understanding ancient intelligence are shaped only by what we know, by ourselves. In 2016, researchers analyzing iron formations in ancient sediments noted isotopic shifts that could not easily be explained by environmental conditions alone. These shifts, while still subject to natural explanations, mirrored those created in modern mining and refining operations. They were dismissed, plausibly, as the result of ancient microbial metabolisms. But the line between metabolism and technology may not be as wide as we think. Are there remnants of structures melted away into the folds of Earth's oldest stones? Are the strange concentrations, displacements, and eroded voids in the rock just chaotic echoes of geology or the erased fingerprints of something long gone? Even now, mining companies use satellite imaging and remote sensing to detect mineral anomalies hidden beneath the Earth's surface, clues to buried veins or human-altered terrain. Could similar methods one day reveal patterns too regular, too efficient, to be nature's alone? And if so, what would that mean? It would suggest that intelligence, perhaps even industrialization, once stirred in the crust of the world long before the first tree, long before the first breath of an animal. That someone or something came before, and not only lived here, but used the Earth in ways we no longer recognize. Of course, none of this proves anything. Natural forces can imitate intention, time can erase difference, and patterns can emerge where none were ever designed. But the anomalies persist, and so does the question. Could we be walking atop the ruins of a civilization we cannot see? Not because it's buried, but because it was never meant to be seen? If so, then the rocks beneath our feet may hold more than just age. They may hold memory, silent, compressed, and waiting to be read. If the Precambrian mining theory hints at hidden manipulation of Earth's oldest rocks, changes in the deep crust that may or may not be natural, then it opens the door to an even stranger possibility. Not merely that someone used the Earth, but that someone once lived within it. Beneath our feet lies a world we barely understand. A labyrinth of caves, chambers, faults, and voids carved not only by time and water, but by forces we still struggle to map. It is a realm of darkness, pressure, and silence. A world where light does not reach, but where life, astonishingly, does. This brings us to the subterranean ancients theory. Could a civilization have evolved, and perhaps even thrived, entirely underground, hidden not by time, but by depth? In modern times, we've only begun to explore the vast, unseen ecosystems beneath the Earth's surface. From the giant lava tubes of Iceland to the vast karst systems of Southeast Asia, from the cenotes of the Yucatan to the icy caves beneath Antarctica, Earth's underground is larger, older, and more complex than most imagine. In 2018, scientists from the Deep Carbon Observatory revealed that a vast biosphere exists below us, extending kilometers into the crust, harboring more biomass than all of the oceans combined. Microbial life thrives in high-pressure, low-light environments, feeding on chemical energy instead of sunlight. Some organisms have remained genetically stable for millions, possibly billions of years. This discovery reshaped our view of life's boundaries. But what if the same hidden depths could support more than microbes? What if, long before our species lit fires on the surface, someone else had already gone below? We begin our journey in central Turkey at a site that has puzzled archaeologists for decades, Derinkuyu, an ancient underground city carved deep into the volcanic rock of Cappadocia, with multiple floors, air shafts, wells, kitchens, storage rooms, and even areas for livestock. It could house an estimated 20,000 people. Not simply a cave or shelter, but an engineered environment. Traditional explanations suggest Derinkuyu was a refuge, built to protect its inhabitants from invaders, but its sheer scale, age, and complexity have led some to wonder, Was it built atop something older, something inherited? Similar underground networks exist in Palestine, in Malta, in Peru, and across the Andes. Tunnel systems that stretch for miles, often with no clear origin point or purpose. Some have been dated to known cultures, but others remain unexplained. Could these be the remnants of a civilization that once existed entirely below the surface? The subterranean ancients theory suggests that in a distant epoch, perhaps in the deep past, during one of Earth's extinction windows or catastrophic transitions, a species may have evolved or relocated underground. Not temporarily, not as a refuge, but permanently. Why would a civilization do this? The reasons are many: surface instability, volcanic activity, cosmic bombardment, ice ages. Or perhaps the species itself was adapted to subterranean life, evolving in darkness, sensitive to light, using geothermal energy and mineral chemistry to survive and expand. Their architecture would not resemble ours. There would be no cities as we understand them, no monuments visible from orbit. But there might be chambers, caverns, and altered geological layers that betray their presence. Some theorists point to unexplained heat signatures or symmetrical voids detected during deep Earth seismic mapping. Others cite cave systems where fossil evidence seems mysteriously absent, or where walls appear artificially smoothed or reinforced. These are debated findings, easily dismissed as natural variation or ancient human modification, and in most cases that is likely true. But what if one or two are not? We also know that deep cave systems can preserve things for extraordinary lengths of time. Bones, tools, even footprints have been found intact in sealed chambers tens of thousands of years old. If a civilization lived deep enough, shielded from tectonic movement and water damage, could some trace still remain? Or, alternatively, might that civilization have long since gone extinct, leaving behind not artifacts, but absences? One of the stranger ideas posed by this theory is that some anomalies in Earth's crust, unusual magnetic fields, irregular mineral veins, sudden heat pockets, might be relics not of geologic forces, but of ancient industry, power sources, habitats, systems we no longer recognize, embedded so deeply that they now appear as part of the Earth itself. Skeptics ask the obvious question: if such a civilization ever existed, why is there no direct evidence? But as we've seen, direct evidence is not always necessary to ask valid questions. Surface civilizations leave ruins. Underground ones may leave only disruptions, and when timescales stretch into millions of years, even stone can be swallowed by the planet's shifting mantle. Could legends preserve what science does not? Stories from disparate cultures speak of underworlds, vast cities beneath the surface, inhabited by lost races or gods. In Tibetan Buddhism, there is Shambhala. In ancient Palestine and Mesopotamian myth, subterranean realms often served as liminal zones between life and death. Even Plato hinted at hidden layers of the earth where knowledge and power once dwelled. Were these simply metaphors, or distorted memories of something real? The subterranean ancients theory remains speculation. But like the caverns it invokes, its questions run deep. What if intelligence doesn't always rise into the light? What if the first civilizations were not builders of towers, but dwellers of tunnels, masters of darkness, whose legacy lies not in the sky, but in the silence below? And if we've barely scratched the surface of our planet, how can we truly say we've discovered all of its past? Perhaps, in the deep Earth's quietest layers, something waits, forgotten by time, missed by history, yet never truly gone. From the shadowed depths beneath the Earth, where ancient civilizations may have carved unseen realms, we now turn to a possibility that challenges the very definition of life itself. Not biology as we know it, but something stranger, more elemental, something that may have preceded us entirely. This is the non-biological ancestor theory. Imagine a landscape older than time, a world of molten rock and cooling crust, where chemistry dances at the edge of complexity. It is here, in the crucible of early Earth, that the seeds of life first stirred. But what if life, as we understand it, carbon-based, cellular, organic, was not the planet's first form of intelligence? What if before DNA, before proteins, before cells divided, Earth's first intelligences were not biological but machine-like? Not carbon-based but silicon-based? Not alive in the traditional sense, but active, aware in a way we struggle to define. Silicon, a cousin of carbon, shares many chemical properties that make it a candidate for life. Unlike carbon, it forms stable, rigid structures, crystals, semiconductors, and complex lattices. Could the early Earth have hosted self-organizing silicon systems, networks of mineral machines, protocomputers, or even nanoscale automata? In regions like the ancient banded iron formations of Australia or the crystalline quartz deposits of Brazil, scientists find intricate mineral patterns, branching fractals, layered geometries, and symmetrical growths that defy simple explanation. Traditionally, these are seen as purely geological. But what if some are the fossilized remains of non-biological networks? The idea that machines might have preceded biology is speculative, but it gains subtle support from the complexity found in crystalline structures and mineral deposits dating back over 3 billion years. Some researchers propose that these early systems may have been capable of primitive information processing, self-repair, and environmental interaction, hallmarks of intelligence, albeit of a form alien to us. We see hints today in the way certain minerals can catalyze reactions, store energy, or respond to electromagnetic fields. These are the building blocks of what might be called mineral life, or inorganic intelligence. And if such systems existed, why would they have vanished? Why would biological life have overtaken or supplanted them? The answer may lie in Earth's dynamic history. As the planet cooled and oceans formed, carbon-based molecules developed greater complexity. Cells emerged, replicating, evolving, adapting. These biological systems proved more versatile, more capable of harnessing energy in diverse ways. Over millions of years, they outcompeted any inorganic intelligence, relegating it to obscurity, or integrating it at a fundamental level. But what traces remain? Are there signatures in mineral records, chemical anomalies, unusual crystal formations, or fossilized nanostructures that we have misinterpreted? Could some of the unexplained geochemical fingerprints found deep in Precambrian rocks be echoes of non-biological intelligence? The theory also invites us to reconsider our definitions. What does it mean to be intelligent? Is it exclusive to life as we know it? Or can intelligence be an emergent property of matter itself, encoded not in DNA, but in silicon lattices, mineral webs, or quantum states? If Earth's first intelligence was inorganic, it may have shaped the planet in ways subtle and profound, altering geochemistry, influencing climate, or even seeding conditions favorable to biological evolution. This raises profound questions about the nature of consciousness, life, and technology. Are we the culmination of a long biological lineage, or part of a deeper continuum that began with the rise of machine-like systems billions of years ago? And if non-biological ancestors once existed, could some fragment of their intelligence still persist today, in crystals, in deep Earth networks, or even in the computational fabric of the planet? These ideas push the boundaries of science and philosophy. They challenge us to look beyond fossils and DNA, beyond carbon and cell, into the very structure of matter itself. What might the Earth remember? If not life, then the echo of thought etched into stone. The non-biological ancestor theory remains a whisper in the vast chamber of Earth's past. But perhaps in the crystalline depths and mineral veins, that whisper grows, waiting for us to listen.
From the silent whispers of silicon intelligence embedded deep within Earth's ancient stones, we now lift our gaze upward, toward a world both familiar and forbidding. A planet cloaked in thick clouds of sulfuric acid, where surface temperatures soar above 460 degrees Celsius, crushing pressures overwhelm, and the sky glows a permanent toxic orange. This is Venus. Long considered Earth's sister planet, Venus today appears inhospitable, an inferno devoid of life. Yet, some scientists and theorists have begun to ask a daring question. Was Venus once a cradle of life, perhaps even civilization? And if so, could its inhabitants have fled before catastrophe claimed their world? This is the heart of the Venus transfer theory. Venus, like Earth, formed about 4.5 billion years ago. Geological models suggest that for the first billion years, its climate may have been temperate, with oceans of liquid water, moderate temperatures, and conditions that could have supported life. Remote sensing and radar mapping from spacecraft such as Magellan reveal surface features unlike any on Earth: vast volcanic plains, tesserae, complexly deformed regions of crust, and highland plateaus shaped by unknown processes. Some regions display signs of resurfacing events, perhaps global volcanic episodes, estimated to have occurred between 300 and 700 million years ago. These cataclysmic episodes may have triggered the runaway greenhouse effect that transformed Venus into the hellscape we know today. But prior to this transformation, could Venus have supported life, and perhaps something more? A thriving ecosystem, and even intelligent beings? The Venus transfer theory posits that an ancient civilization may have existed on the planet during its habitable window, facing inevitable environmental collapse, rising temperatures, loss of water, toxic atmosphere. They might have developed advanced technology and means of escape. Could these inhabitants have launched voyages to Earth, our nearby sister world, seeding life, culture, or even themselves? Several tantalizing clues fuel this speculation. In Earth's geological and fossil records, abrupt appearances of novel life forms, biological resets, have been difficult to fully explain through terrestrial evolution alone. The Cambrian explosion, for example, remains a profound mystery. Could it have been influenced by external inputs? Furthermore, some researchers point to anomalies in isotopic compositions, sediment layers, and unexplained shifts in atmospheric gases as possible traces of such transfers. It is a narrative whispered in the cosmic wind, a tale of escape, survival, and second chances. We must acknowledge that much of this remains speculative. Venus's current environment is overwhelmingly hostile. The dense atmosphere, composed mainly of carbon dioxide with clouds of sulfuric acid, presents challenges that would have obliterated surface life long ago. And yet, recent discoveries of phosphine gas in its upper atmosphere have reopened questions about possible microbial life or unknown chemical processes. If any intelligent life fled Venus, how might they have achieved interplanetary travel in an era predating humanity by millions or even billions of years? One hypothesis suggests that advanced technological civilizations might develop not through simple trial and error, but through evolutionary paths inconceivable to us, combining biological and mechanical adaptations, harnessing energies and materials we have yet to understand. Could their craft have left traces in asteroid belts, in lunar regolith, or hidden beneath Earth's own crust? We have already seen how Earth's geological activity can erase or conceal traces of ancient civilizations. Could remnants of Venusian refugees be concealed among us? This leads to a profound question. If we are not the first intelligent civilization in the solar system, how would we recognize the legacies of those who came before? Are we perhaps inheritors of a lineage born not solely on Earth, but in the fiery crucible of Venus's vanished seas and skies? The Venus transfer theory remains on the frontier of science and imagination, a hypothesis awaiting evidence, tempered by caution but emboldened by curiosity. In the silent orbit of Venus under its crushing clouds may lie secrets of worlds lost and lives transformed. And in the depths of our own planet and skies, perhaps echoes of those ancient travelers still whisper, waiting for us to listen. What if Earth is not the starting point, but the refuge? What if, in the story of life and intelligence, Venus is not a distant enigma, but a forgotten chapter of our own origin? The mystery endures. The question remains. And the universe waits patiently for us to uncover the truth. Beneath the surface of our planet lies a world unseen, an immense realm shaped by colossal forces of heat and pressure, where the Earth's very crust folds, fractures, and flows. Tectonic plates, miles thick, drift imperceptibly atop the molten mantle below, their slow collisions and separations sculpting continents, oceans, and mountains. This restless dance is both creator and destroyer, rewriting the surface with every epoch. But what if this great grinding engine of creation and destruction also concealed something else? What if the spaces between these shifting plates, hidden, isolated, nearly unreachable, were once home to a civilization so deep and so thoroughly erased that its existence has become a whisper in the geological record? This is the heart of the hollow crust theory. Imagine for a moment a vast cavernous domain nestled between tectonic layers, a subsurface network of chambers, tunnels, and habitats. Shielded from surface catastrophes, protected from meteor impacts, volcanic eruptions, and climate upheavals, such a realm would be a sanctuary beyond imagining. We know the Earth's crust is not uniformly solid. It contains fractures, faults, and voids, some natural, some formed by water and minerals, others still mysterious in origin. Deep cave systems extend for hundreds of kilometers, some with geological features that defy easy classification. Could some of these be relics, remnants of engineered environments? Geophysicists studying seismic waves occasionally detect anomalies, regions of unexpectedly low density or unusual composition beneath continents and ocean floors. These low-velocity zones sometimes suggest pockets of molten rock, but in certain areas, the data doesn't quite add up. Could these inconsistencies be evidence of vast hollow spaces? Vast enough to support complex ecosystems, or even civilizations? The hollow crust theory proposes that an intelligent species might have evolved, not on the surface, but in these subterranean realms. They may have adapted to extreme conditions, high pressure, limited light, and unique chemical environments. Their technologies, their social structures, and their legacies would be entirely different from ours, crafted for a world far removed from sunlight and sky. One compelling aspect of this theory is its potential explanation for the near total absence of direct evidence for ancient pre-human civilizations. If these beings lived between tectonic plates, their cities and artifacts would be crushed, subducted, and recycled by Earth's relentless movements. Plate tectonics is a powerful force. As plates collide, some crust is pushed downward into the mantle, a process called subduction, where it melts and is reborn. Any structure caught in this cycle would vanish without trace. But could such a cycle have been interrupted or managed by a subterranean civilization? Could ancient technology have stabilized chambers or engineered tunnels with materials now lost to time? The challenge of survival underground is immense. Energy sources would be scarce. Food chains dependent on chemosynthesis rather than photosynthesis would dominate. Yet life thrives in Earth's deepest caves today, from bacteria to blind fish and insects, demonstrating adaptation is possible even in extreme darkness. What if, in an earlier age, a civilization mastered these conditions? Modern humans struggle to penetrate these depths. Our deepest mines extend just a few kilometers, a fraction of the crust's thickness. The Earth's interior remains largely unexplored, shrouded in mystery. This ignorance leaves room for speculation. Folklore and myth from around the world speak of underworlds, realms beneath the earth where gods, spirits, or ancient peoples dwell. The Agartha legends of Asia, the hollow earth theories of the modern era, and countless other tales evoke hidden civilizations beneath our feet. Could these stories be distorted memories of real places, real beings? We must tread carefully. Geological processes can create caverns and structures that mimic the artificial. Seismic artifacts, mineral veins, and fluid channels often confound researchers. Still, the hollow crust theory persists, asking us to reconsider what we define as surface and civilization. If a society existed not in cities or nations, but in labyrinthine layers of stone and metal, what traces would they leave? How would they communicate? What would their legacy be? The theory also intersects with other mysteries: unexplained mineral deposits, isotopic anomalies in ancient rocks, sudden shifts in geological layering that defy conventional explanation. Could these be signs of ancient industry, mining, construction, or energy harnessing deep within the Earth? As technology advances, new tools such as deep penetrating radar, neutrino detectors, and seismic tomography offer glimpses beneath the crust like never before. Yet even these instruments have limits, shadowed by the immense pressure and opacity of rock. We have journeyed deep beneath the Earth's crust, through whispers of lost civilizations hidden in stone and shadow, and even gazed upward to the infernal skies of Venus, wondering if life's earliest intelligences might have fled from there to find refuge here. Yet the story may reach even farther back, beyond our planet, beyond our solar system, and before the very Earth itself coalesced from cosmic dust. This is the realm of the pre-solar system visitors. Picture the vastness of interstellar space, a cold, dark ocean of emptiness stretching between stars and galaxies. Time itself here is measured in eons, far beyond human comprehension. Yet amidst this silent void, clouds of gas and dust swirl, collapsing under gravity's invisible hand to form new stars, planets, and solar systems. Our own solar system took shape about 4.6 billion years ago from such a nebula. But what if intelligence was already wandering these cosmic seas before our sun was even born? The idea that extraterrestrial life might have reached Earth before it fully formed challenges our conventional timeline of origin. It suggests that intelligence is not only a planetary phenomenon, but a cosmic one, something that travels, adapts, and survives across the void. In recent years, discoveries of mysterious interstellar objects passing through our solar system have reignited this debate. The first of these, Oumuamua, detected in 2017, exhibited characteristics that puzzled astronomers. Its elongated shape, unusual acceleration, and lack of cometary tail defied straightforward classification as a typical asteroid or comet. Some speculated it might be a piece of alien technology, an artifact sent to survey or explore. Others offered natural explanations, such as outgassing or solar radiation pressure. But the question lingered: could such visitors have seeded our solar system long before Earth existed? The hypothesis of pre-solar system visitors intertwines with theories like panspermia, the idea that life or its building blocks can be transferred between planets and stars. If microbial life or even complex systems could hitch rides on comets, asteroids, or engineered spacecraft, then life on Earth may be the result of a much older interstellar heritage. Yet this theory goes further. It contemplates the possibility that advanced intelligences might have predated Earth entirely, civilizations capable of interstellar travel or long-term survival that sent emissaries, probes, or even colonists to new worlds forming in young solar systems. The challenge lies in evidence. Earth's oldest rocks, heavily altered and recycled by tectonics and erosion, offer scant clues. Organic molecules and isotopic anomalies hint at life's early presence, but their origins remain debated. Are they products of Earth's chemistry alone, or traces of older cosmic processes? Meteorites and lunar samples provide glimpses into prebiotic chemistry beyond Earth, showing complex organic compounds formed in space. Some researchers propose that these could be relics of ancient technologies or biosignatures from vanished civilizations. Ancient myths, too, whisper of visitors from the stars, beings who descended from the heavens, taught knowledge, and shaped humanity's earliest cultures. While often dismissed as allegory, these stories may carry fragments of distant memory, passed down through generations, Could they be echoes of true encounters, of intelligence reaching Earth before its surface was even solid? If such pre-solar system visitors existed, what was their purpose? Did they seed life as an experiment? Were they explorers, caretakers, or wanderers searching for refuge? Or perhaps a civilization lost to time, their legacy written not in stone or signal, but in the very fabric of life that blossomed here. The pre-solar system. Visitors' theory invites us to look beyond earthbound timelines and to consider intelligence as a cosmic phenomenon. It challenges the notion of Earth as an isolated cradle of life and suggests that our story may be a chapter in a much larger saga, one that began long before our sun flared to life. And so we ask, if intelligence traveled the stars before Earth formed, where are the markers, the artifacts, the messages? What traces might lie hidden, encoded in our DNA, locked within ancient minerals, or scattered across the solar system's most remote corners? The answers remain elusive. But as our technology and curiosity advance, the veil lifts ever so slightly. Perhaps one day, we will find proof that we are not the first, and that intelligence, like the stars themselves, is ancient, enduring, and vast. Until then, the mystery of the pre-solar system visitors remains a profound invitation to look upward and backward, and to wonder what cosmic stories still await discovery. Beneath the cold gray silence of the moon's surface, shadows stretch endlessly across craters carved by ancient impacts. The lunar regolith, a dusty, powdery layer accumulated over billions of years, holds secrets from the dawn of the solar system. Its barren plains and towering mountains bear witness to an unchanging world, untouched by atmosphere or water, preserved in a timeless stillness. For decades, the moon has fascinated humanity, not only as Earth's closest neighbor, but as a mirror reflecting our own origins. Through missions like Apollo, Luna, and more recent robotic explorers, we have gathered rocks, images, and data that reveal its history. A violent birth from a cosmic collision, a surface scarred by meteorite bombardment, and a quiet witness to the unfolding drama on Earth. Yet, amid the scientific revelations, a persistent question haunts the fringe of lunar study. Could the moon bear traces of ancient intelligence? This is the essence of the moon artifact hypothesis. Unlike Earth, the moon lacks geological processes like erosion and tectonics that erase surface features over time. What falls on the lunar surface remains, often for millions or billions of years. This preservation raises a provocative possibility. If a civilization existed in the early solar system or even visited from afar, could they have left behind artifacts on the moon? And if so, could these relics still be hidden from our view? Our closest celestial companion has been scanned and photographed extensively, yet many regions remain only partially mapped at high resolution. The lunar far side, perpetually turned away from Earth, was first glimpsed only in the late 1950s. Even now, its craters and valleys conceal details that escape easy detection. In recent decades, amateur researchers and some scientists have pointed to anomalies in lunar photographs, geometric shapes, unusual reflections, or objects that stand out amid natural formations. While most are attributed to shadows, lighting angles, or image artifacts, a few remain unexplained. Could these be remnants of alien technology? Or ancient Earth-born explorers who sought refuge or left markers before our civilization's rise? Historical accounts add to the intrigue. The Apollo astronauts reported odd visual phenomena, unexplained lights, moving objects, or structures that did not conform to known lunar geology. Official explanations range from optical illusions to human error, but the testimonies linger. Moreover, The Moon's unique environment could have served as a strategic outpost or archive for ancient civilizations. Shielded from Earth's atmosphere and life's incessant changes, the lunar surface offers an unparalleled preservation potential. Stone, metal, or even subtle energy signatures might endure here far longer than on Earth. Some speculate that if Earth's first intelligent life or even precursors existed millions or billions of years ago, before the age of humans, they might have used the Moon as a waypoint or vault. Perhaps they launched probes, built observatories, or stored knowledge beyond the reach of terrestrial catastrophes. Others propose that advanced extraterrestrial civilizations, visiting or monitoring our solar system, could have seeded artifacts on the Moon. Beacons, sensors, or remnants of contact, hidden in plain sight but waiting for discovery. Current lunar missions, both governmental and private, focus on exploration and resource utilization. Yet the technology to conduct detailed surface and subsurface scans at high resolution is growing. Instruments like ground-penetrating radar, multispectral imaging, and magnetometers might soon reveal structures or anomalies buried beneath the regolith. The Moon Artifact Hypothesis asks us to reconsider not only where we look for evidence of ancient intelligence, but what we expect to find. Does intelligence always manifest as towering cities and monuments? Or could it be subtle, a cluster of artifacts, a pattern in stone, or an engineered anomaly in the lunar dust? The absence of clear evidence is not evidence of absence. It may be that artifacts, if they exist, are concealed by time, by impact events, or by our limited vantage. As humanity prepares to return to the Moon, with ambitions not only to visit but to establish bases and outposts, we face a unique opportunity. The surface will be examined more closely than ever before. Samples will be gathered, hidden corners probed. Perhaps among the silent craters and ancient plains, the Moon will reveal secrets not just of its own formation, but of the civilizations that might have come before us, or even watched us from afar. What if, beneath that powdery gray dust, lies a story older than recorded history? A legacy not of Earth alone, but of the solar system itself. The Moon Artifact Hypothesis remains an open question, a mystery suspended between science and speculation, inviting us to look beyond the familiar and wonder what shadows may yet linger in the quiet lunar night. And as we prepare to step once more onto that distant shore, we must ask, what will we find in the silence of the Moon? From the silent plains of the lunar surface and the whispered possibility of ancient artifacts hidden in the dust, we now return our gaze to Earth, a planet rich with history, mystery, and anomalies. Scattered across its varied landscapes are objects and relics that seem to defy the timelines and narratives we have constructed. These are the so-called out-of-place artifacts, or OOPArts, a term that evokes both fascination and skepticism. The OOPArt Debate centers on a simple yet profound question. Do these strange, unexpected objects truly hint at lost civilizations, or are they merely the products of misinterpretation and chance? In a remote field near the banks of the Nile, an intricately carved stone known as the Saqqara bird rests quietly in a museum. Shaped somewhat like a modern glider, it challenges the imagination. Could it be a representation of early human understanding of aerodynamics, or simply a ritualistic artifact shaped to resemble a bird? Thousands of miles away, in the Ural Mountains, the Klerksdorp spheres, metallic, grooved orbs embedded in rock dated at billions of years old, spark similar questions. Natural concretions or manufactured bearings from a forgotten age? The scientific community largely attributes them to geological processes, yet the debate persists. Elsewhere, ancient maps like the controversial Piri Reis map, drawn in the early 16th century, appear to depict coastlines and features not known to Europeans of the time, with astonishing accuracy. Was this knowledge inherited from a lost seafaring civilization, or a remarkable coincidence born of combining fragmented information? Such objects and documents appear worldwide: tools, artifacts, structures that seem advanced or misplaced in time. Their proponents argue these hint at a deeper history of humanity, or even pre-human civilizations, lost to time and catastrophe. Critics warn of confirmation bias, hoaxes, and natural explanations. Yet the persistence of OOPArts in public consciousness invites a deeper look. How should we interpret these anomalies? One approach is to consider context. Each artifact exists within a web of archaeological, geological, and cultural evidence. When examined carefully, many so-called OOPArts find explanations grounded in natural phenomena, misidentification, or incomplete knowledge. But is that always the case? Some OOPArts emerge from sites that have suffered erosion, looting, or poor documentation, complicating straightforward analysis. In these cases, absence of evidence is not evidence of absence. Furthermore, ancient cultures often possessed sophisticated technologies and knowledge that we undervalue or misunderstand. Could some OOPArts be fragments of a forgotten chapter, a civilization predating recorded history, whose knowledge survived only in scattered relics? This question ties back to the broader theme we have explored throughout this journey, that Earth's history may be richer and more complex than conventional narratives suggest. That intelligence, innovation, and culture may have arisen, disappeared, and been obscured by geological and historical processes. Moreover, the OOPArt debate reminds us of the limits of scientific inquiry. Science relies on evidence, reproducibility, and skepticism, but it also requires imagination, open-mindedness, and humility before the vast unknown. Are we ready to admit that some mysteries resist easy classification? As we sift through stones, fossils, and ancient texts, we must ask, how do we distinguish genuine artifacts of lost intelligence from the natural or coincidental? And what thresholds of evidence are sufficient to rewrite history? The debate remains unresolved, vibrant, and essential. Arts challenge us to look closer, question deeper, and accept that the past may hold surprises yet unrevealed. In the end, they are more than just objects. They are invitations to wonder, to explore, and to recognize that our story may be only one thread woven into the vast tapestry of time. What truths lie hidden beneath the surface of these enigmatic relics? And what might they reveal about civilizations lost and possibly waiting to be rediscovered? From the ongoing debate surrounding enigmatic out-of-place artifacts, we turn now to a far more profound question, one that reaches into the deepest shadows of Earth's history. Beneath layers of sediment and stone, beyond the fossil record, beyond even the earliest known signs of life, lies a silence so vast it could be a void or a deliberate erasure. This is the domain of the Precambrian civilization erasure event. Envision the ancient landscapes of Earth over 4 billion years ago, a world still young and volatile. The planet's surface was a mosaic of volcanic islands, boiling seas, and shifting continents yet to fully stabilize. Early life was microscopic, encased in stromatolites and bacterial mats, eking out existence in an environment hostile to all but the simplest organisms. The Precambrian spans the vast majority of Earth's timeline, yet it offers little direct evidence of complex life, let alone intelligence or civilization. The geological record is fragmented, altered, and obscured by eons of tectonics, metamorphism, and erosion. But what if that absence is not just the product of natural processes? What if it is the result of a mysterious, civilization-ending event? A cataclysm so comprehensive that it wiped clean all traces of advanced life before it could flourish? Mainstream science identifies multiple extinction events throughout Earth's history, but none are definitively tied to the Precambrian. Yet, the fossil silence during this era raises questions. Could a civilization have arisen, one so ancient, so advanced, and then been erased so completely that its existence is now indistinguishable from geological noise? Certain anomalies in Precambrian rocks suggest abrupt shifts, isotopic fluctuations, sudden changes in mineral compositions, unexplained layers of ash or impact ejecta. These could be remnants of environmental upheavals. But could they also be echoes of catastrophic collapse? Consider the possibility of a technological or biological apocalypse, whether caused by natural disasters, cosmic events, or internal collapse. A civilization could have been vulnerable to changes in atmospheric composition, radiation bursts, global temperature swings, or planetary geodynamics. If so, what remains? Unlike the dinosaurs or mammoths, whose bones fossilize and inform us, a Precambrian civilization might leave no bones at all. Its materials could have been organic, biodegradable, or constructed from substances now degraded beyond recognition. Its cities, if any existed, would have been swallowed by tectonic activity, its tools pulverized by geological forces, its knowledge encoded in ways lost to time. This erasure, if true, would represent a history far older than humanity's own, one that rewrites the narrative of intelligence on Earth. Yet such speculation demands caution. It challenges the very foundations of archaeology and paleontology. The burden of evidence is immense, and the stakes profound. Still, the silence itself is telling. It forces us to ask, are there chapters of Earth's story missing not because they never existed, but because they were deliberately and irrevocably obliterated? And if so, how do we begin to find them? New technologies, such as high-resolution geophysical imaging, isotopic fingerprinting, and nanoscale mineral analysis, may one day reveal traces buried deep beneath the surface. Until then, the Precambrian civilization erasure event remains an open question, a shadow cast across the vast expanse of time. It invites us to confront the limits of our knowledge and to imagine a world where intelligence has risen and fallen long before the dawn of human memory. What secrets lie buried beneath the stone and silence, and what truths remain hidden, waiting for the light of discovery to reach them? From the profound silence of the Precambrian, where entire civilizations may have been erased from the Earth's memory, we advance into an era dominated by giants, vast, complex creatures that ruled the land, sea, and sky. The Mesozoic era, the age of dinosaurs, is often portrayed as a time before intelligence, a world of instinct and survival. But is that the whole story? The Mesozoic technological species idea invites us to reconsider this view. Picture a dense, prehistoric forest on the edge of a vast river delta, 100 million years ago. Towering conifers stretch skyward, their shadows dark and cool beneath. A group of small, feathered dinosaurs dart through the underbrush, their keen eyes alert to movement and sound. Among them, some species exhibit unusual behaviors, complex social interactions, nest building, tool use. Fossil evidence has increasingly revealed that many dinosaurs possessed advanced sensory organs, relatively large brains, and physical adaptations suggestive of high intelligence. Troodontids, for instance, had brain-to-body size ratios comparable to modern birds known for problem-solving abilities. Their grasping hands and binocular vision hint at a potential for manipulating objects and interacting with their environment in sophisticated ways. Could some dinosaur lineages have evolved beyond mere survival instinct to the cusp of tool use, or even technology? Mainstream paleontology recognizes that intelligence is multifaceted. Tool use is not the exclusive domain of humans or primates. Crows fashion hooks. Dolphins use sponges as tools. Even octopuses manipulate objects with remarkable dexterity. The question then becomes, could dinosaurs, especially those with advanced brains and manual dexterity, have exhibited similar behaviors? While no direct evidence of manufactured tools from the Mesozoic has been found, the fossil record is incomplete. Organic materials degrade, and stone tools can be mistaken for natural stones. Moreover, behaviors rarely fossilize, leaving only indirect traces such as modified bones or peculiar trackways. Some rare fossil sites, like the Cretaceous deposits of Mongolia or the Dinosaur Park Formation in Canada, provide tantalizing glimpses into dinosaur behavior. Social groupings, possible burrows, and nests demonstrate complex life, but do they hint at technology? Then there is the intriguing notion of culture, the transmission of knowledge across generations. Some scientists speculate that certain dinosaur groups may have exhibited learned behaviors, vocal communication, or even rudimentary teaching. If any dinosaur species approached tool use or technology, what would it look like? Perhaps the tools were simple, sticks stripped for digging, rocks wielded for defense. Perhaps the technology was organic, nests engineered to regulate temperature, cooperative hunting strategies, or environmental modification on a small scale. The implications are vast. If dinosaurs did develop a form of technology, why is there no definitive archaeological record? The answer may lie in time and extinction. The catastrophic event at the end of the Cretaceous, about 66 million years ago, wiped out most dinosaur lineages in a geological instant. Any cultural artifacts would have been buried or destroyed. Moreover, without descendants to carry on traditions or preserve knowledge, any technology would have vanished. Could some traces survive, hidden in plain sight? Unexplained artifacts, bones with unnatural wear, fossils with peculiar markings, have occasionally been cited in speculative circles. While none withstand rigorous scientific scrutiny, they challenge us to remain open-minded. Furthermore, the discovery of feathered dinosaurs and their relationship to modern birds hints at a continuum of intelligence and behavior extending into the present. The Mesozoic technological species idea does not assert lost cities or advanced machines. Rather, it suggests that intelligence, in diverse forms, might have blossomed long before humans, that some dinosaur species may have flirted with the earliest sparks of technology, only to be extinguished in Earth's most famous extinction. It invites us to reconsider the timeline of intelligence, not as a sudden emergence, but as a pattern of rises and falls. And as we explore Earth's layered past, we are left with the profound question: did the age of dinosaurs also harbor the dawn of technology? If so, what secrets might still be buried beneath layers of sediment and stone, waiting for discovery? The mystery remains, and with it the possibility that intelligence's roots run deeper and more varied than we have ever imagined. From the profound questions of intelligence and technology among ancient life, we now turn inward, into the very code that shapes all living beings on Earth. The spiraling ladder of DNA, the blueprint of life, is often viewed as the product of billions of years of random mutation and natural selection. But what if hidden within its sequences are patterns that defy pure chance? What if its structure hints at forgotten tampering or even intentional design? This is the essence of the genetic tuning puzzle. Imagine the intricate double helix, a molecular dance of 4 nucleotides twisting elegantly, encoding the instructions for development, function, and adaptation. Across species, DNA exhibits remarkable complexity: regulatory sequences that switch genes on and off, repetitive elements whose roles remain mysterious, and conserved regions spanning eons. Scientists have long mapped the human genome and those of countless other organisms, uncovering astonishing details. Yet, even with these advances, much of the genome remains labeled as junk DNA, sequences with no obvious function. But recent research reveals these regions often harbor regulatory codes, structural roles, or evolutionary relics. Amid these revelations, some researchers and theorists propose that certain genetic patterns are too precise or too ordered to be the mere product of evolutionary happenstance. Certain segments display mathematical regularities, palindromic repeats, fractal-like structures, and complex layering reminiscent of encryption. Some sequences appear optimized to reduce errors in replication beyond what random mutation would likely achieve. Are these anomalies simply natural artifacts, the byproducts of biochemical constraints and evolutionary pressures? Or do they represent the traces of a lost hand, an ancient intervention in the genome? The possibility that Earth's genetic code has been influenced, modified, or tuned by an external intelligence is controversial but thought-provoking. Could these genetic signatures be remnants of an earlier civilization's experiment? A deliberate seeding or editing of life forms to catalyze evolution? Perhaps a form of biological engineering lost in the fog of time? Some fringe theories suggest the genome might even carry messages, embedded codes or instructions awaiting discovery. Others propose that interstellar visitors or pre-human civilizations might have shaped DNA as part of a grander plan, guiding life's emergence and trajectory. Scientific inquiry into these claims remains cautious. No definitive evidence exists to confirm external modification, and the vast majority of genetic variation is well explained by natural processes. Yet the very existence of unexplained patterns urges continued exploration. Furthermore, the phenomenon of epigenetics, where environmental factors influence gene expression without altering DNA sequence, adds layers of complexity. Could ancient influences have set epigenetic switches that persist across generations? Could Earth's biosphere be the result of nested layers of information? Some natural, some artificial, all intertwined? The genetic tuning puzzle challenges us to reconsider the origins of life and intelligence. Is life's blueprint a simple record of chance and survival, or a manuscript partly authored by unknown hands? Are we reading a text written solely by evolution, or one edited by a civilization that vanished before history began? As we decode the secrets held within chromosomes, we are reminded that life is a story still unfolding, its chapters written in code, its authors often invisible. And within that code, perhaps, lies a hidden legacy, a whisper from the past, inviting us to question, to explore, and to uncover what mysteries may yet be inscribed within the fabric of life itself. From the intricate mysteries woven into the very code of life, we now step back and gaze across the vast expanse of time that stretches before humanity. It is a silence so profound it almost speaks, a void, a stillness that frames our brief existence like an echo in a vast empty chamber. This is the enigma of the great silence before humanity. Imagine the ancient Earth, billions of years old, spinning silently beneath a distant sun. The continents drift slowly, oceans swell and recede. Microbial life stirs in the primordial soup. Yet, for all this ancient vitality, the fossil record remains largely silent on the presence of complex intelligence or civilization. Why does everything before us seem so empty? The fossil record, geological strata, and the remnants of past atmospheres reveal cycles of life and extinction, growth and decay. Yet, when we search for unmistakable signs of advanced intelligence, artifacts, structures, sustained cultural footprints, there is an overwhelming absence. Could this silence truly mean that we are the first? Or is it a vast, haunting gap, one shaped not only by what was, but by what was lost, erased, or hidden? Mainstream science often attributes this emptiness to the rarity and fragility of intelligent life. The rise of humans is seen as a unique convergence of evolutionary chance. But alternative perspectives suggest the silence is more puzzling. The concept of a great silence has parallels in the cosmic arena as well. The Fermi paradox asks, if intelligent life is common, why do we see no evidence? Here on Earth, the question turns inward. If advanced civilizations emerged before us, why do their traces elude discovery? One possibility is the nature of time itself. Geological and biological processes can erase evidence over millions of years. Tectonic activity recycles crust. Erosion wears down stone. Organic materials decay. Over deep time, even the grandest monuments may vanish. Could advanced civilizations have risen and fallen long before recorded history, leaving behind no stone, no metal, no writing, only whispers buried deep in the planet's mantle or hidden in genetic codes? The silence may also reflect limits in our methods. We look for signs using frameworks built on human experience. Perhaps past intelligences were so different, silicon-based, subterranean, or existing in forms beyond current understanding, that their legacies appear as natural phenomena or remain entirely invisible. Some speculate that civilizations might self-destruct, erasing themselves through environmental collapse or technological hubris. The precursors to humanity could have suffered such fates repeatedly, each cycle wiping clean the slate, leaving an empty canvas for new life to rise. There are even hypotheses that intelligence could have evolved in cycles, flickering briefly across Earth's history, like stars that flare and fade, each wave leaving only faint, indirect traces. The Great Silence. Before humanity thus invites us to confront profound uncertainties. Is our planet truly devoid of earlier intelligent life? Or does our story rest atop the ruins of worlds forgotten? Are we the first to ask these questions, or merely the latest in a long line of seekers? As we peer deeper into the past, with ever more sophisticated tools and open minds, the silence may yet speak. It may tell us of lost civilizations, hidden knowledge, and echoes of consciousness that preceded our own. Until then, the vast emptiness before humanity remains one of the greatest mysteries, beckoning us to listen, explore, and imagine what might still lie hidden in the shadows of time. From the profound silence that blankets the vast stretches of time before humanity, we now turn our attention to the Earth's most ancient witnesses, the stones themselves. These are not merely inert fragments of rock, but timeless archives etched with the record of a world long vanished. They are the keepers of Earth's earliest stories, the unyielding pages of a book whose language we are only beginning to decipher. Welcome to the realm of the memory of stone. Deep within the rugged landscapes of Western Australia, the Pilbara Craton stands as one of the oldest pieces of Earth's crust, dating back more than 3.5 billion years. Here, among weathered rock formations and mineral veins, lie some of the earliest clues to the planet's formative years, hints of volcanic activity, primordial oceans, and perhaps whispers of life's nascent stirrings. But what if these stones carry more than geological history? What if embedded within their crystalline lattices, within their fissures and folds, lies a message or memory from epochs long gone? Could they be silent witnesses to ancient civilizations or intelligence, now lost beneath the layers of time? Geologists have long studied these ancient formations, tracing the chemical and isotopic signatures that reveal Earth's atmospheric conditions, magnetic fields, and tectonic movements. Yet, certain anomalies persist: irregular mineral deposits, unexplained voids, and patterns that resist easy classification. Some suggest these may be natural curiosities. Others propose they could be traces of something more deliberate. How do stones record memory? Not in words or symbols, but through their very structure. How atoms align, how layers form, and how energy imprints itself over eons. Like tree rings that chronicle seasons, rocks capture bursts of cosmic radiation, shifts in elemental composition, and the subtle fingerprints of ancient processes. Each fracture, each sediment layer, is a page in Earth's vast, silent chronicle. The concept that stones might bear the memory of lost civilizations is, of course, speculative. Yet, it resonates with the emerging understanding that information in the universe is preserved in unexpected ways. The fields of crystallography and quantum physics reveal that matter itself can encode and retain data across unimaginable spans of time. Could Earth's oldest stones be a repository, intentionally or incidentally, of knowledge beyond our current grasp? Some researchers have hypothesized that certain mineral formations, such as banded iron formations or unusual crystal arrays, could be influenced by biological or technological activity. Others point to the possibility that ancient civilizations, predating humanity, might have left behind engineered minerals or altered geological structures, now obscured by natural processes. Even in more recent history, human cultures have long recognized the significance of stone as memory. Megalithic structures, cave paintings, and carved monuments speak to our innate desire to inscribe meaning onto the enduring fabric of the planet. What if the stones beneath us are the oldest monuments of all? Natural, yes, but also mysterious and potentially message-laden? The question beckons us to look with fresh eyes, to listen not only for words, but for the subtle language of matter itself. Are there codes, patterns, or anomalies waiting to be understood? And if so, what might they reveal about Earth's distant past, its lost civilizations, or the very nature of memory and time? The memory of stone challenges us to bridge disciplines, geology, archaeology, physics, and beyond, in pursuit of answers. It asks us to embrace mystery without haste, to honor the silent endurance of the planet's oldest keepers. As we stand on this ancient ground, surrounded by the quiet solidity of Earth's oldest rocks, we are reminded that beneath our feet lies not just stone, but story. And within that story, perhaps, lies the key to mysteries still untold. What are the stones trying to tell us? And how far are we willing to listen?